Ladies and gentlemen, friends and colleagues, good morning, good afternoon, good evening, and welcome to our workshop on the grand challenges and opportunities in the global management of chemicals and waste. My name is Martin Scheringer, and I'm the chair of the International Panel on Chemical Pollution, IPCP. I'm a chemist by training, and I work at two places, in Switzerland at the Swiss Federal Institute of Technology in Zurich, and in the Czech Republic at the Recitox at the Masaryk University in Brno. I would also like to introduce my colleague, Miriam Diamond, who is a professor at the University of Toronto and the vice chair of the IPCP. Miriam and I will be the moderators of the workshop today. The IPCP is an association of academic scientists working on chemical pollution problems. It was founded in 2008, and its members come from many different scientific disciplines and from all areas in the world. The mandate of the IPCP is to foster the transfer of scientific knowledge to the public and to decision makers, and also to support international exchange, international collaboration, capacity building. And this also includes, for example, the workshop today. If you're interested in the work of the IPCP or in becoming a member, please visit our website at ipcp.ch. At the beginning of the workshop today, I would like to make an important clarification. And this is that there is no connection whatsoever between the IPCP as a private organization and a possible intergovernmental body on chemicals and waste. The role of the IPCP is, in this process, is just to enable the discussion about such a body and to prepare input for political decision makers. What are the goals of the workshop today? I think it's not an exaggeration if we say that we have reached a critical point in human history. Humanity is facing multiple global crises, including obviously climate change, biodiversity loss, chemical pollution, but also others such as soil loss and water scarcity. In contrast to climate change and biodiversity loss, chemical pollution has received less attention by the global community until recently, when the United Nations Environment Assembly, UNEA, adopted chemical pollution as a working priority of UNEP for the period of time from 2022 to 2025, next to climate change and biodiversity loss. UNEA, the United Nations Environment Assembly, will meet again in February next year, so in a couple of months, and will negotiate a set of resolutions that will influence the course of chemical pollution and how it is handled at the global level. This will include the question of a global convention on marine litter and microplastics, and also the question of how the intergovernmental science policy interface of chemicals and waste can be improved and enhanced. The IPCP welcomes this important step in moving the chemicals and waste issue forward globally. To support the decision-making by UNEA and other international organizations, IPCP board members and colleagues have developed a proposal for establishing a global science policy body on chemicals and waste. And this was published in the journal Science earlier this year. Subsequently, the IPCP also launched a sign-on campaign and has received the support of more than 1,800 scientists and practitioners from many regions of the world, from more than 80 countries. And the proposal described in the article in Science has also been received by governments, with the government of Switzerland announcing that together with some other UN member states, they will submit a proposal for establishing a global science policy body that would be then negotiated at the upcoming UNEA meeting in February. The workshop of today builds on the science paper and the sign-on campaign. We are very excited and happy to have distinguished speakers and long-term experts from different parts of the world to share their views and knowledge. And the presentations by the four speakers will be followed by a panel discussion where then a broader picture can be discussed. And this panel discussion will also be joined by colleagues from the government of Switzerland, which then makes it possible for us to discuss their forthcoming proposal on establishing a global science policy body on chemicals and waste. In conclusion, I would say it has become obvious now that the current situation globally and also locally in many parts of the world is not sustainable regarding chemicals and beyond. We cannot go on like this, and we have to act. So let's at least try to change the narrative today, and let us bring the global efforts addressing chemicals and waste to the level where they should be. Before I now introduce the speakers, I would like to thank several of the IPCP board members and others who have helped with the preparation of the workshop. In particular, Professor Penny Vlahos from the University of Connecticut in the United States, and Professor Thomas Backhaus from the University of Gothenburg in Sweden, and Anna Söll as the Executive Director of the IPCP and other IPCP board members for providing the technical infrastructure that makes this workshop possible. Now I give the floor to Penny for her opening remarks.
Thank you, Martin. I would like to reiterate the significant amount of support from key individuals who went into making this workshop happen. The University of Connecticut, namely Deb Schuler, who set up the registration logistics, from the University of Gothenburg, Dr. Thomas Backhaus and Asa Arrhenius for managing the meeting logistics and for hosting today's workshop. Thank you. To Sarah Veshapar from the University of Toronto, who designed the workshop graphic, and finally Anna Söll, who is the backbone of the IPCP and who seamlessly integrated all the parts to make this workshop happen. So today's workshop brings together next slide, please.
Sorry, that is me.
Yeah. So today's workshop brings together over 400 and almost 480 registrants from over 70 countries to add to the momentum of this important effort and to bring a diverse group of perspectives to the table. We thank all of you for your participation in the workshop today, and sincerely thank our speakers for spearheading these conversations. There is currently no unified source of information on chemical pollutants, nor guidance to nations on vetted chemical policy. This delays progress and leads to uninformed and unfortunately even misinformed management and unnecessary exposure to and risk to humans, biota, and ecosystem health. We recognize that the introduction of pollutants in our global environment has reached new peaks, and we face among the highest human exposure levels to xenobiotic compounds in our history. It is through this recognition that we emphasize the importance of strengthening science policy interactions through a comprehensive plan. Thank you again for attending today, and I pass the platform back to Martin.
Thank you very much, Penny, for this additional important perspective on what we are doing here today and why. Now, I would like to turn to the speakers, and if we can get started in a minute or two, I just wanted to share with all of you, the overall workshop schedule. We have had the introductory remarks now. Now the next block will be the 4 presentations, and each speaker will speak for about 20 minutes, and then there is time for questions and answers regarding the technical or the content of the presentations. And then after the 4 presentations, there is the panel discussion where the speakers will be present and will be joined by Felix Wertli from the Swiss government and Zhanyun Wang from the IPCP. And then there is also room for a broader discussion of many issues that may come up. If you want to ask a question, please do this via the chat in Zoom. And then we will monitor the questions and pass them on to the speakers. If there's any problem you may encounter, then please send an email to admin@ipcp.ch. And with this, I think I stop sharing my slides here, and I would like to give the floor to our first speaker, who is Professor Satoru Morishita, who will speak about chemicals and waste management with a co-benefit approach for sustainability. Satoru Morishita spent about 34 years in the Japanese Environment Agency and Ministry of the Environment, working on climate change, waste management, and the 3 Rs of reducing, reusing, and recycling waste, as well as management of chemicals and environmental pollutants. From 1997 to 2000, he served at the Secretariat at the Environment Directorate of the OECD. After leaving the post of Vice Minister for Global Environmental Affairs at the Japanese Environment Agency and Ministry for the Environment in July 2020, he joined IDEA Consultants and is currently serving as Executive Vice President and President of IDEA's Institute of Environmental Ecology. And from April 2021 on, he has served at Ibaraki University as a visiting professor. Professor Morishita, the floor is yours.
Thank you very much, Martin, and thank you very much for inviting me to participate in this very important workshop. And I'm very pleased, and also I'm very excited to deliver a talk in this workshop. And today's my talk is, the focus will be on sustainability for futures, chemicals, and waste management. I think more consideration should be given for ensuring and enhancing sustainability, and a benefit approach is the key. That's my message, my main message. And actually, I was a governmental official as introduced by Martin. I have more than 34 years experience at Japanese Ministry of the Environment. And at that time, I worked on climate change as Vice Minister and other environmental issues such as chemicals and waste management, 3R policy, reduce, reuse, recycling, and recovery and destruction of HFCs. And I've also got deeply engaged in chemicals related conventions such as Basel, Stockholm, Rotterdam, and Minamata Mercury and Kigali Amendment as well, for their adoption and implementation in Japan. So based on my experience today, I'm very excited to talk about this title. Next slide, please. And this is my introduction, so please skip it. Next slide, please. Okay, so let me start with decarbonization, climate change. Undoubtedly, climate change is one of the most serious global threats for us, and net zero societies in 2050 is a global challenge. And for shifting to decarbonization, it's been said that there are two basic approaches. Firstly, let's transform existing energy-related systems. We need to further promote energy saving, use of renewables, and global electrification. Electricity supply should also be decarbonized, and development of sustainable fuel is needed, in particular for airplanes and heavy duties. In order to offset residual emissions that are emitted after all reasonable efforts made by private companies from their oil operations, it will be necessary to make use of so-called negative emissions technologies such as DAC, direct air capture. Secondly, this is a horizontal axis. Let's transform current socio-economic systems to more decarbonized ones. And for that purpose, a perspective of sustainability should be injected when designing new systems, for example, circular economy, smart agriculture, and innovative food systems. In doing so, attention should be fully given to achieve climate neutrality and other SDGs in a simultaneous way, which will be able to lead to minimizing of GHG emissions, as well as improving resource efficiencies, minimizing biodiversity loss, and avoiding damages to people's health and the environment as much as possible. Next slide, please. Okay, thank you. Then how we can move forward? Are there any clues? How does science can assist to transform existing systems? Here, I would like to share with you Global Sustainable Report in 2019. That is a very useful guidance document prepared for UN Secretary General Guterres at the timing of Climate Action Summit in New York. The report emphasizes the importance of systemic approach for sustainability based on science. And in the preface of this report, Madame Brundtland wrote, "The true transformative potential of the 2030 agenda can be realized through a systemic approach that helps identify and manage trade-offs while maximizing co-benefits." Next slide, please. Then what kind of co-benefits exist? Here, a couple of examples. First, creation of circular economy. Circular economy can contribute to improvement of resource efficiency as well as reduction of CO2 generation. It is noteworthy that about 45% of global CO2 generation are from extraction of materials and manufacturing of products. Here, I should not forget to mention management of chemicals in products and of course wastes is critically important for avoiding any damages to health and the environment when we develop circular economy. Secondly, food systems. Food systems have a large reduction potential of greenhouse gases, including methane and nitrous oxide. Enhanced food systems can provide food, nutrition, while minimizing food wastes and reducing greenhouse gases. Thirdly, biodiversity. It's been pointed out that nature-based solutions can contribute to climate mitigation and reduction of biodiversity loss at the same time. Ecosystem-based disaster risk reduction is an approach that can bring multiple benefits in disaster reduction and enhanced biodiversity. Improved management of plastics can be beneficial in terms of circular economy and biodiversity. Next slide, please. Thank you. Then before discussing actions for future chemicals and wastes management, I would like to draw your attention in terms of chemicals management. There are two types of circular systems functioning, and the co-benefit approach needs to be incorporated into these systems. One is manufacturing related system on the left, and the other is nature related systems on the right. For sustainability, management of the left-hand side system is required to cover entire life cycle stages of products, from extraction of materials to manufacturing, transport, and recycling and disposal. Advanced IoT technology can play an important role to keep tracking of chemicals-related information throughout supply chain of products, not only from the viewpoint of health and the environment, but also climate, biodiversity, and human rights. Focus should be given to plastics, metals, hazardous chemicals in products and wastes, and those contained in equipment. Previously, I mentioned for decarbonization, global electrification is necessary, but is copper adequately available for that purpose, which we do not know at this moment, and more deliberate consideration is necessary, I think. On the right, the nature-related system is based on use of nature, and recently there is an increased voice that an insight of so-called localization of SDGs is an efficient and effective approach. Since nature-based systems depend on diverse local conditions such as weather, landscape, and culture or history, so sustainable systems need to be designed on a site-by-site basis. Attention should be placed on how to use lands and oceans. One example is related to chemical accidents and spatial planning. Natural hazard triggered accidents, for example, due to flooding, earthquakes, they are avoidable through better spatial planning. So prevention of chemical accident is beneficial, not only for the companies and the people in the vicinity, it is also very valuable in terms of finance. And so it may be able to attract attention of finance sector, such as ESG investment. Next slide, please. Oh, sorry. Before that, I just want to say two things. Oh, thank you. So transformation of food systems contributes to reducing greenhouse gas emissions along their supply chain. Due attention should be given to the use of plastics on lands in the agriculture sector, and distribution of plastics in the environmental media needs to be carefully monitored. And next slide, please. Thank you. Here in this slide, I would like to show you what action will be needed on the global and the local basis for future chemicals management. Globally, sharing knowledge on chemicals and enhanced network among a variety of scientists with particular focus on sustainability should be strengthened. In terms of health and the environment, in fact, many priority areas are already identified. For example, substitution of hazardous chemicals with less harm alternatives, and development of risk assessment and risk management methodologies, and development of criteria for sustainable plastics from a chemicals perspective. In particular, I would like to emphasize the importance of sharing information on chemicals in products along the value chain. This is a real weak point for creating circular economy. companies that put products on the market often do not know the chemicals that are contained in their products. It may be wise to use only additives that facilitate recycling. For example, non-hazardous chemicals and or colorless materials. Moving away from animal tests is a big challenge, and we need an international vision on how risk assessment needs to evolve without using animals. And I should mention that still many countries do not have adequate legislations on chemicals in place that would allow them to regulate chemicals in a proper manner. This is a top priority issue for global chemicals management. It will be beneficial to provide those countries with more simplified risk assessment and management methodologies so that they can more easily embark on chemicals management without further delay. I believe in those already identified priority areas, the OECD should continue to take the leading role as they have done so far. In addition, from the viewpoint of sustainability, I think more efforts are needed to work on value chain management of chemicals. Collection and recovery of CFCs and HFCs from the air conditioners is an example. On a regular basis, action should be designed to provide practical solutions, taking into account the conditions of individual areas. More focus should be on agriculture and food systems, behavioral changes using advanced technologies. Generation of renewable energy and hydrogen production may have conflicts in the future with food production, since both needs vast lands. So use of lands and probably oceans needs to be carefully designed and monitored so that critical damages to social and economic activities can be minimized. And in doing so, the co-benefit approach will be able to provide maximized benefits while reduction of trade-offs in a concrete manner. Next slide, please. None. And this is my last slide. Since I was a governmental official and based on my personal experiences, I tend to think that policy makers are not always fully aware of what are priority issues in a comprehensive way. In many cases, relevant information is not available or scattered, and it is very difficult for them to understand the issues in a holistic way. So the consequence is no action. So I would like to encourage scientific communities to consider three things. Firstly, increased sharing of data in terms of sustainability. Secondly, strengthened scientific networks related to sustainability. Thirdly, and lastly, there is a need of development of clear guidance to policymakers for enhanced chemicals and waste management in terms of sustainability by using co-benefit approach. Thank you very much for your attention. That's it.
Thank you very much for this very interesting overview and highlight of some of the also future problems that we may face in the development of more sustainable technology and society, and also for keeping the time exactly on the minute. So we do have time for comments and questions from the audience. And I have received one question already via the chat that concerns the question of data availability. And the question is about companies and why they don't share more information on the chemical content of their products and perhaps they may not even know, but some of them may know. So that was one question, or one part of the question. And also, is there a need for an international or globally synchronized database on these kind of data on chemical contents in products?
Yeah, thank you very much for those questions. They are all, I think, important, and also I'm very much interested in those kind of the issues. And the first thing that I should mention is, the companies do not want to review everything, because it's very important to have some technical specialties in their products. So there is a tendency that they do not want to review everything. So we have to take into account such kind of attitudes of the companies. It's very natural for them to do so, and taking into account that, but we have to develop something in particular in terms of hazardous materials. So that will allow us to, create a supply chain management of chemicals and also the products which contains hazardous chemicals. So we need some kind of, agreement between the environment and health, and also business societies. So we have to put more emphasis on that, so to create something. So
do you think that should be voluntary, or do you think something compulsory would be needed?
It depends on the importance of the issues, and we definitely need regulatory something. But in addition to that, maybe more, frameworks can be designed to include sustainability perspectives. So many approaches will be available in front of us, and I encourage the scientific communities to provide, advanced and innovative solutions or ideas on that.
Okay, thank you. There's a next question coming up. Sorry, I just have to take a look at the chat here. And the question is, how can we balance the need to recycle versus reducing production in the first place and consumption, because recycling itself is energy intensive and technologically difficult and imperfect? So the balance of making more stuff and trying to recycle it versus making less stuff.
Yeah. So for me, the best approach may be the reducing, reusing, and recycling. So-called the 3R approach is most promising approach. And in addition to that, at the production stage, more consideration should be paid how we can minimize energy use and also the loss of materials. So sustainable consumption and production is a keyword in this world, and balance should also taken into account. And let me offer you one example which is taking place in Japan for increasing recyclability of PET bottles. In fact, PET bottles in Japanese, PET bottles that are manufactured in Japan are all colorless. This is not a regulation, and this is a completely companies' voluntary initiative, but they have agreed upon that in order to increase recyclability of the plastics PET bottles, they decided, they have agreed upon that, they use only transparent materials, colorless materials. So Japanese PET bottles are all colorless, which contribute to the improvement of the recyclability. So some kind of balance, but it of course requires some more energy, but in the end, in a total, the energy required for producing PET bottles can be minimized. So we have to think more, life cycle management approach for considering future waste management systems. Thank you.
Yep, thank you. There is a question that's related to this somehow. I just have to pick some now from the many questions that are coming in. So this question that I see that is related is, it says, does the notion of circular economies imply that we have to make products simpler and with fewer chemical ingredients? Because you said we need to try to recycle wherever possible, but then, yeah, what can we do, or what do we need to do to support recycling?
I think the most important approach is, sharing information on chemicals throughout the supply chain. In some chemicals category, maybe, more additives may be necessary in some specific purposes, but considering it, the impact to the environment in overall, we may be able to find the approach, that will be able to reduce additives, unnecessary or the harmful additives in some kind of products. Still, there are some rooms for that purpose. So we have to encourage the importance of the product management in terms of the chemicals more aggressively. That's my feeling.
Yeah, thank you. Perhaps a last point, again, going back to the question of data availability, also from companies in chemical products, the question of a database, and again, an international database that could be established and is available to everyone. What do you think we need to support this? Of course, this is possible technically, somebody could just start, but what do you think would be needed to really make this sufficiently comprehensive and up to date?
I think, global database will require a bunch of efforts, money, human resources, and I'm not sure if it will works in a proper manner. And it depends on the countries or the regions. They can make a decision on that. If country X make a decision of making such a database, that's fine. They have to do that, but that should be the initiative of those countries. The rest of the world cannot go along with that idea. So we have to understand other countries' situations. So maybe it is very important to encourage the information sharing between different countries, but it is at this moment a little bit not practical to develop a global database on such a purposes. Of course, it depends on purposes. For some very specific items, there might be some possibility of making such a global database, but we have to consider what kind of benefits can provide by the development of such global database. It will be time consuming and resource consuming, and it will require a lot of human resources and money, and then what is the benefit is also that should be taken into account. Thank you.
Absolutely, yes. Perhaps as a last point, and you don't have to say a lot, but this question now comes from me. This is, could you, or what is your opinion about the intergovernmental body on chemicals and waste? Could that play a role in all this, or what is your view on that?
Yeah, I anticipate that question. And as I mentioned in my talk, I think sustainability perspective needs to be incorporated into the chemicals and waste management. And I feel something is missing. And I encourage the scientific communities to identify what is missing piece of the current arrangement. And also, I would like to ask the scientists to, identify what are the issues of top priorities in terms of sustainability. So the scientific communities will be able to show us, including the policymakers, and what kind of benefits will be provided by those kind of new initiatives. So that's my expectation. Thank you.
Okay, thank you. We may come back to that in the panel discussion, I guess.
Yeah.
Thank you again,
Thank you.
Satoru Morishita, for the talk and the discussion. And we now move on to our next presentation. And let me introduce our next speaker. And this is Björn Hansen. And the title of Björn's talk is Safe and Sustainable Chemistry, the Scientific Challenges and Opportunities of Regulations. Björn Hansen is the second executive director of the European Chemicals Agency, ECHA, and he took on this position in January 2018, but Björn has been involved in international chemicals work since 1991. Earlier in his career, after a postdoc in probability theory in Germany, Björn joined the European Commission in 1991. He then first worked at the European Chemicals Bureau at the Joint Research Center of the Commission in Italy, and then from 2003 on in the chemicals unit of the DG Director General Environment of the European Commission in Brussels. There, Björn became the head of unit in 2012, and he already spent a year at ECHA in 2007-2008 as Director of Operations. And Björn Hansen has been involved, or was involved in the development of the European Chemicals Regulation REACH from early on. So now we are very glad that you are here to talk with us about these questions, Björn, and the floor is yours.
Thank you very, very much, Martin. And as Satoru, I'm very grateful for having this opportunity to participate in the workshop, and in particular to be able to give you an address of 20 minutes of some thoughts. I'm going to focus in on a few areas that Satoru talked about from two facets I'm reducing. The one is the types of chemicals that I'm going to be talking about. The way I see the world, there are 5 types of chemicals: biocides, plant protection products, pharmaceuticals, veterinary medicines, and then industrial chemicals. And I'll talk about the latter. And that's mainly because that's where my experience is, and also that of the agency and the policy work that I've done in my career. But also because the other areas are, if there's regulation there, are generally governed through an authorization system, where it's easier to tackle changed policy objectives in authorization systems than it is in an industrial chemicals program. But I still believe that much of what I say is equally valid there. But again, it comes from the chemicals angle, the most of the experience. The second part is I'm going to home in and look at it from a regulatory scientist perspective. So basically look at the world from a regulatory agency, and then maybe come with some reflections on what we need, but also what we have. And a reflection on where we're going. Now, what is a regulatory agency in my view? Well, in general, even though, again, when you look at details, it probably differs where you are in the world. But very often what we do is we take information, we develop efficient processes to process such information to make a regulatory outcome who is designed to make an impact to help a policy. So basically information, process, and in a process you have tools to do risk assessment, socioeconomic analysis and stuff like that. You have a regulatory decision and policy. And if I start with policy, what my competence and what the focus of my forward-looking ideas are mainly on the process and regulatory decisions. But of course, we need to have a common view on what policy we're actually aiming at for that to make sense. So I'll spend a few words on policy. And to me, of course, the Sustainable Development Goals are a beautiful framework to say that's worldwide policy. That's what we want to achieve collectively together in whatever position or not we're in as a world citizen, but also if we're fortunate enough to have a government job or an industry job or a job in any sector, any place where we can contribute. if I look at the Sustainable Development Goals, then a lot of them basically generate market demand for new chemicals, better chemicals, or other uses of the chemicals we got. So they are the demand drivers of chemicals. If you look at clean water and sanitation, chemicals can help. If you look at zero hunger, chemicals can help. Good health and well-being, chemicals can help reach that sustainable development goal. And there are many others where chemicals can help, and markets basically will drive innovation in order to get those chemicals to good use to meet those sustainable development goals. On the other hand, chemicals also have negative aspects, the undesired properties of chemicals. They're also captured in a number of the sustainable development goals. And those are the ones where the market in itself does not drive them out very often. So there's a push, that's to get chemicals off the market that we don't need based on those sustainable development goals, which are impacted due to undesirable properties of chemicals. And we leave market forces as the main driver for where the chemicals provide solutions. If you look at those goals which are going to drive chemicals off the market, then the three things in those goals that I see driving chemicals off the market, it's an increased desire level of protection that is wanted in countries, in regions, but also worldwide, which you see clearly in the Sustainable Development Goals and their whole history from 1992 onward. There is a clear objective of circularity, meaning very, very crudely speaking, it means we should not landfill any more substances, materials, products. We should no longer incinerate or burn them, energy recover being the politically correct version, because that is resource inefficient. We should have it all in a circle, which basically means that rather than landfilling, we house fill. And in the house filling, we therefore have quite a few additional aspects of safety to look at, because all chemicals will be around for a long time. And then the third challenge that is pushing chemicals off the market will definitely be climate neutrality and moving from high energy intensive chemistries to low intensive energy intensive chemistries. Also in 2050, therefore, to me, chemicals and waste will be one and the same. I can't predict what the vocabulary will be, but I sure hope that we're going to find a vocabulary that covers both, so that we don't have our comfortable silos to work from, but we have one joint way of looking at the world. And basically, we have chemicals, which are the building blocks, and we have the materials, which are the mixtures of chemicals. And whether it's waste or not is not the issue. The issue is it safe? Is it properly circular, reusable, and can it be recycled, manufactured at low energy? And of course, that circularity is broad. It goes from circularity of the molecules, going via, for example, biosourcing. So the circularity, including agriculture or including even the environment, all the way to the more current type of looking at recycling, that you want recycling of materials. So I think that's how policy is looking, and those are the demands that come on chemicals and waste. But again, chemicals and waste in a number of years should be one and the same. Challenge and a prize to anybody who finds one term that covers both. What are then the type of policy decisions that that will be driving that change from a regulatory perspective? Because what regulation does, it catches those who are lagging behind. And we need that in a system of change. If we're changing, and in particular, changing as fast as the Sustainable Development Goals are requiring us to do, we need a lot of push and a lot of pull in order to enable industry to have the security of the innovation it needs to meet both be the solution provider for a lot of the Sustainable Development Goals, but also to make sure that it doesn't cause problems in others. And on the push side, what I see, what we see is definitely that there is a push in policy to want to be more predictive, more preventive in its policy making, and definitely wants to accelerate. So the decisions that come out from regulation need to not only be an assessment of current day risks and problems, but also should be predictive of the future in order to avoid them even occurring. Since the assessment techniques we have are rather slow, there's also an acceleration needed. Then we go to the tools to supply that type of framing of policy decisions to meet the policy, which clearly is mapped out in the Sustainable Development Goals. Excuse me, I'll take something to drink while I speak. And there, the types of tools that are being developed and need to be developed in order to answer those policy or address those policy decisions, meeting the policy objectives of the Sustainable Development Goals. We have clearly the necessity of having predictive toxicology in order to accelerate and in order to be more predictive. And predictive toxicology goes hand in hand with what Satoru mentioned about animal welfare. So it's a win-win situation in terms of becoming better predictors, moving faster, and also saving animals. Then there's the concepts of generic risk management, which is a term crowned in Europe. But what it basically means is how can we get more predictive based on the hazards of the chemical to prevent future uses from even occurring where we expect there to be a risk. Those are methodologies that are coming. And then clearly grouping of chemicals in order to accelerate, but also to better understand the toxicity of one individual chemical from those of others. Now, those three tools, generic risk management, predictive toxicology, and grouping, play very, very nicely into the shortfalls of current regulatory systems of chemicals. Currently, most systems on regulation of chemicals actually manage to find the worst point in time to regulate a chemical from a business perspective. Normally, the way a business is run is you synthesize a little chemical in small doses, you do a bit of in vitro testing and computer modeling if possible, and then eventually, as your product gets commercial success and your investment into supply chains, into uses, into advertisement, into customer relations starts going up and the tonnage starts increasing, then once you hit a high tonnage, you start testing. And it's with those high tonnage testing that you find out that the chemical actually has the properties that are such that you should never have marketed the substances up front. And this is exactly the time when you're starting to reap in the profits, or where industry starts reaping in the profits. So basically, our regulatory systems at the moment are designed to maximize friction between protection and business interest. And that's something that predictive toxicology, generic risk management, where you look more at preventing problems from occurring upfront based on hazards of chemicals and knowledge and experience we have on uses, will enable that friction to be significantly reduced. And then the grouping bit will also enable us to avoid what is often called regrettable substitution. That industry, of course, because their production facility is one that can only be perturbed to move from one molecule to one that's slightly different, but not totally different, of course, in order to survive on the market, need to exactly move from one molecule to another and cannot make huge jumps. And hence, there is, of course, a tendency to end up substituting with similar compounds. And if we're able to assess jointly groups of chemicals, we can actually help industry target those compounds which are least risky, rather than it being a little bit of a random walk on a whole group of chemicals, costing lots of money, creating lots of inefficiencies, and ultimately also impacting negatively on health and the environment. So basically, those are some of the tools and processes which I think can help us globally in order to meet these increased demands on safety, circularity, and on energy efficiency. Now, let me come with a few reflections on circularity and waste and energy efficiency and its relationship to chemicals. And then I'll close off by talking about what I started saying is the starting point of all this is information. First of all, on circularity, I think in order to get an appreciation of the challenge that industry is facing, I think it's good to put three things together. The one is the increased demand on safety of chemicals. And we already know how difficult it is to predict properties of chemicals. And that is a conditionality on the innovation that we're putting on industry. The second one, circularity. At the moment, there are very, very few circular materials, and now I'm being polite. Almost all materials have a finite lifespan, or they can only be recycled if they are partially virgin material added. And of course, if you look at circularity and you actually have good collection, then this is a business model where there will be exponential growth of the material you have. And there the question is, at some point, is that actually the material that you want to exponentially grow or not? And that's the sustainability question when you get to the planet limits in terms of circularity and materials. If I look at climate neutrality, then I think one of the main challenges will be what part of the climate change challenge can chemicals and waste, but again, whenever I say chemicals in the future, chemicals and waste should be one and the same, but what part of the whole problem can the chemicals policy or can the chemicals area actually take care of? First of all, it's clear it shouldn't do everything, because otherwise there's no job for all the other colleagues who are doing the work on climate change and climate mitigation and all of these things. So there needs to be a delineation between what we can do with our competences and what others can do with their competences. And this, I think, is a very important thing in terms of talking about chemicals and all the sustainable development goals, is to delineate what can we do effectively and better than others. And I think what we have in our hands that can be done better is that what we are good at is looking at what is inherently the properties of a chemical. And a lot of other things which are downstream, we observe, but we don't have in our hands. And I think that is the starting point to find out where to delineate how much of the climate change problematic can we contribute to solving. And then finally, to information. And then I think I'm getting slowly to the end of my talk. Information is, of course, the basis of which anybody and everybody can take decisions. And the trick and the challenge, I think, will be to find out which information do we actually need to have an efficient and consistent decision-making system to push off the chemicals that we don't want on this globe in order to meet the sustainable development goals, but then at the same time set the goals so clearly that we can foster innovation in order to get those chemicals on the market which we really want. And I believe that if we analyze better what information is actually needed to do regulation, then we'll see that that we don't always need all the information that's out there, but that in some areas the information is not there. So we can rationalize and make a much more efficient system if we jointly look more at what information is needed for regulatory decision making, what information is needed for innovation before actually designing these systems, and then we can target much better the collection of the information. But of course, in order to meet just such sustainable development goals as zero hunger, quality education, gender equality, and reduced inequalities, all this information needs to be freely available to all. Competition between companies should not be allowed to work on having or not having information. The competition that we would want needs to be on using the information to the good of the planet and meeting the Sustainable Development Goals. So thank you very much, and looking forward to the questions and answers and the further part of this workshop.
Thank you very much, Björn. That has been a very rich and also provocative talk to some extent at least. And I liked your point about chemicals and waste being the same. Hopefully, the sooner the better. So I think there are lots of starting points for discussion, and I'm just skimming the questions that are coming in. I would like with one that is, again, a bit provocative, probably not now to you, because of course, many of the things you have mentioned are promising and are to be pursued. But aren't we running out of time? Because we already have a lot of chemicals out in the environment that should not be there, and they are detrimental. We know that. So how can the things that we need to improve that situation, how can these things be developed, implemented, whatever, earlier, more quickly, whatever? So because we have discussed these questions, of course, for a while already. So how can we make it not just happen, but make it faster and more effective?
I think that the best way of speeding up is to have a joint understanding that there is an urgency. If I look back at the 30 years I've been around on international chemicals management, then it was those moments in time where urgency was recognized by all players. So governments, citizens, academics, industry. Those are the times when you can really move forward, because that's when you understand that you have a common goal and sacrifices need to be made. And I think we're at one of those points. I think, you look at climate events the last couple of years, these were the ones that 10 years ago were predicted to happen in 20 years. You look at some of the chemicals that we thought we would have been controlling by now, but end up actually not being. I mean, microplastics, intentionally added microplastics, the PFAS chemistries. We see that we have not been effective. So there needs to be urgency, but then we also have to accept that there are, we need to accelerate the system, and the acceleration of the system goes at certain costs. There will be winners, but there will also be losers. And I think we are getting there in terms of articulating the urgency and agreeing on that. And I think that there needs to be a bit more discussion on what are the tools, because there are very limited tools available for us to actually get that urgency to decision makers, but also, I mean, decision makers in companies in terms of innovation, but also decision makers who are working for public authorities.
Yes, thank you. I fully agree. I think with climate, we have seen many events, many disasters, and it's more visible and the urgency is more obvious. Whereas for chemicals, they are mostly invisible, and therefore probably this is the reason why there is a lack of urgency still. And I agree, we need to have a better sense of this urgency. Now there are coming some questions that are connected somehow, and they ask for the role of scientists and the support of the scientific side for the regulatory process beyond what we have already. Of course, we do have lots of panels and groups and contacts between regulators and scientists, but what is your vision or also your wish? What do you think is a need for a more effective input from the scientific side?
I think there's, as always, it takes two to tango, and we're both doing something wrong since we're not quite getting there as we want to. And I think it's regulatory science. If I say that that's what I'm representing at the moment, I would say it's us articulating exactly what we need better to answer the regulatory questions to fall into line with the policy objectives. And I think it's also for science then to work better at targeting its science to what regulators need. There's both sides of it. And I mean, I was an academic before I joined the Commission. My daughter is an academic. So I mean, I understand the academic world and the academic pressures, and I don't want to in any way criticize the way it functions. Just want to say that if there can be a bit more targeting of science to regulatory questions, which very often are not very scientific, but they're extremely impactful. That could maybe be one of these amplifiers of getting there.
Good. I think we will come back to that question also in the panel discussion, I'm sure. Another question, again, a bit provocative, is, do we really need more chemicals to deliver the SDGs? Because there are so many already on the market. Can't we choose from them, or can we do without chemical or without additional ones?
I hope I didn't say that, and I'm sorry if I was understood to being said that. No, we need different chemicals. If you simply look at not even what is very often labeled the chemical issue, which is safety, just take that one aside and just look at circularity and look at climate neutrality. Those two already tell you the chemicals we got today are not the ones that we can have tomorrow. We need other ones. Circularity, I mean, which materials are circular today? There's not a plastic which is circular without adding virgin material. Adding virgin material is linear. So there are very, very few circular materials. The next thing is, how is it that most chemicals are being produced? Well, if you're going from, if the sourcing is petroleum, then you do it at very high energy consumption. We got to get away from high energy consumption chemical manufacture. So climate neutrality can only be met not only if the supply becomes green, but also if the demand decreases. I mean, in the European Treaty of the functioning of the European Union, you have the environment principles, and one of them is address pollution at source. And that basically means if you can reduce energy consumption, and start out with. So those alone tell you we got a massive challenge on the chemistries that we need. And then on top of that comes more safety. Industry has a lot to do, and we really, really need to help them.
Okay, thank you. I think that makes good sense, and is a strong response to that question. Another one is, what would a regulatory information instrument similar to the safety data sheet but serving the goal of circularity look like? So something that indicates the suitability of a chemical to be used in materials for recycling. Could that be indicated by a sheet?
Let's say, a very great question. You're putting me on the spot. So what you're getting here is a bit of a brainstorm on gathering a bit of things here. On the energy efficiency side, there's no absolute scale, I think. So that makes it more difficult. Whenever you have an absolute scale, it's easy to put into a safety data sheet. When you have relative scales, that scale will keep changing. It's like in Europe with our energy labels, where you go from A to A plus to A plus plus, A plus plus, and everybody gets confused. And it's much more difficult to set a good target for industry. So on the energy side, I don't know enough, but on the recyclability side, I definitely can see it, because I mean, fundamentally, there are two types of recycling, right? There's chemical recycling, where basically you're using waste as the new raw material to produce chemicals. You have to do it low energy, which means that the molecules have to be bound in a different way than they're bound today if you want to do chemical recycling at lower energy. And then you have the material recycling, which is more physical processing, but then you need a different chemistry in order to provide those materials. And I think there, in the material recycling, we already have ISO standards and stuff like that. I'm sure that we can develop industry can develop ISO standards on chemical recycling in terms of purity, in terms of energy efficiency and stuff like that. So there I can see, a safety data sheet or a sustainability data sheet being passed on, so that consumers can choose, but also companies can choose.
Yep. So a recyclability sheet, yes. Very good idea. I think that was a great question. I like that one. Perhaps as the last one, because then we will have a quick break of 5 minutes before we move on to the third talk. But for a last one for you, Björn, and you don't have to. It takes up something we have already had, but so you don't have to really say a lot. But still, it irks me. And it says, what is the barrier to regulating and phasing out chemicals we know they are dangerous? Is there not enough science? Or what else is it?
I do want to do the education too, so I'm going to say one sentence on that one. But I think the barriers are that you need tools to take scientific decisions on which regulators can make their regulation. And tools are there to provide consistency and efficiency. And I think that the tool development goes relatively slow because there needs to be broad consensus. But I do think that if I look at a number of the tools that are being developed and have been developed, I mean, if I take a non-EU thing, you know, take the Canadian system of risk management, they've developed tools. There are tools being developed which show that one can take robust scientific decisions a lot faster, simply because we can sort back through all the information and find that information which is actually important for a regulatory decision and drop the rest. We need to get that acceptance that that is also scientific. You don't need to write 1,000 pages if you just write the 10 good ones. Good examples is the EU's intentional microplastic restriction, I think, or ban, which basically just says microplastic is not very good when it's in the environment. Let's not keep it. Let's make sure it doesn't get there. On education, key. I mean, all of us think the way we do because of our education, because of our parents, because of what our training afterwards. The new generation will only think like this if it starts. And this is not just university education, where of course it needs to be. It's down to preschool. It's down to school. It's education is the foundation to having the mind open to create the innovations we need. It's too late when you're a chemist and you're 27 and then somebody tells you, oh, make sure it's not a PBT. You know, that's a bit too late.
Yes, great. Thank you. That is a perfect, I guess, last word, if I may say that. Thank you very much for this very engaging discussion. And thank you again, Björn, for talk and discussion. And I would like to introduce our third speaker, who is Marian Nkansah, and she will speak about destinations for global e-waste, the case of environmental pollution in Ghana. Marian Nkansah is an associate professor at the Department of Chemistry of the Kwame Nkrumah University of Science and Technology in Kumasi in Ghana. Marian's research involves levels and fate of toxic substances, including heavy metals, trace metals, persistent organic pollutants, polycyclic aromatic hydrocarbons in different environmental matrices. Marian also received training in science diplomacy and science advice for policy, and is a member of the Royal Society of Chemistry and an affiliate of the IUPAC, the International Union of Pure and Applied Chemistry. She is also a member of the Global Young Academy, an affiliate of the World Academy of Sciences and the African Academy of Sciences, a member of the Ghana Young Academy, and a fellow of the Next Einsteins Forum. It's a pleasure to have you here, Marian. Thank you for your willingness to provide your insights and thoughts, and the floor is yours.
Thank you very much, Martin, and greetings to all the audience, and thanks to the organizers for doing this. I'm very happy to be part. So I'll be speaking on destinations for global e-waste, the case of environmental pollution in Ghana. Next slide, please. My presentation will take this outline. I'll look at background to the concept of e-waste, particularly having in mind an audience which is not expert. So the experts might know this, but those who are not essentially experts in this field will have something new to learn. And then I'll look a little bit at some work that has been done in Ghana, and then concluding remarks and my sources of information. Next slide, please. So electronic equipment, basically appliances that require power supply to function or battery to function. And when there's no use for these at the end of the day, then they are referred to as e-waste or waste electric and electronic equipment. In the year 2004, The legal term WE was coined, which refers to waste electric and electronic equipment. And so this is what has been used since. Next slide, please. Yeah, there has been a number of regulations to control the movement of e-waste from one jurisdiction to the other. And major among them are the Basel Convention of 1989 and the Bamako Convention of 1991 and the Rotterdam Convention of 1998. Next slide, please. Most jurisdictions derive their regulations surrounding e-waste from these conventions. And because of the challenges associated with enforcing proper transport or recycling of waste generated from these sources, some of the regulations suffer in certain jurisdictions. And currently, e-waste regulations from most countries include restrictions on the import and export, regulations on recycling of specific categories, and then the expanded producer responsibility, which gives the disposal and management of the electric or electronic equipment after use to the producer. So the producer is taxed at the point of production to be responsible for the disposal at the end of use. Next slide, please. In the year 2017, globally, about 50 million tons of e-waste was generated. And it was estimated that by the end of this year, 52.2 million tons will be generated. Next slide, please. Next. And then out of this number that was generated in 2017, 10% of that was recycled, while about 60 to 90% were exported to Africa, Asia, and other jurisdictions. And in Africa, Ghana, Nigeria, Ivory Coast, and the Democratic Republic of Congo were topping the list. Next, please. E-waste movement to developing countries follows sometimes informal routes. They are packaged sometimes as second-hand or scrap, and some also don't even follow the well-approved borders and end up in these jurisdictions. It was estimated that about $12 billion is generated annually from this kind of trade. Next, please. E-waste, as all scientists might know, contain toxic substances that can be harmful to humans and also to the environment. And interestingly, some of the products also can be repaired and reused by patrons, and also in certain instances contain recoverable precious metals of economic value. Next slide, please. And then due to the ever-changing technological evolution when it comes to e-gadgets, the waste products that are generated or the second-hand versions of these gadgets have also become of very high demand in the jurisdictions that they end up in. Next slide, please. Therefore, the movement of e-waste to least developed countries is a growing trend which seems to have no end in sight, due to either the lack of strict regulations or lack of enforcement in most cases. Next slide, please. There's also the general preference for second-hand versions of high-end brands, since there's a general perception that if those same brands happen to be found on the markets as brand new, they might come across as being imitations or versions which are not as durable as the second-hand versions that have been imported. Next slide, please. Therefore, the e-waste industry is a very vibrant part of the informal sector in most developing countries, and the practice thrives due to the improved livelihood that it offers to patrons and then the service providers as well. Next slide, please. Now, the electric and electronic equipment industry in Ghana and the e-waste situation, I would like to present some information from this point onwards. Next slide, please. Yeah, so Ghana is party to these international treaties. I will not mention all the Basel Convention, the Vienna Convention, Montreal, going through to the strategic approach to international chemicals management. And all these are supposed to guide the import and export and also the disposal of waste from these sources in the country. Next slide, please. Now, this diagram gives us an idea of the distribution of electric and electronic equipment and also the second-hand versions in the country, as well as the waste that is generated from them. And it is estimated that about 215,000 tons of electric and electronic equipment are imported into Ghana annually. And out of this number, 30% are brand new, while 70% are second-hand. And out of the 70% second-hand equipment, 15% are broken down and have no use at all. Next slide, please. In Ghana, the exploration or the trade in e-waste or equipment, electrical and electronic equipment generally is dominant in two large cities, the capital, which is Accra, and then Kumasi, the second largest region. And the processes that occur can be seen in this diagram, where there's scavenging on your extreme left of your screen of the electric and electronic items by sorting. And after sorting, those that are of value are sold right away to households or industries. Those that are not useful at that point are dismantled, and spare parts can be used for repairs and sold. And then out of that too, there's the extraction for the precious metals, where unwanted parts are disposed, not following very approved methods of disposal. And the extracted metals normally are traded both nationally and internationally. The issue here is that most of these activities are done with no regard for safe environmental practices, as well as the use of PPEs even to protect those involved in these activities. Next slide, please. Yeah, so these pictures show you some of the activities that happen in the yards, both in Accra and Kumasi. There's normally sorting and arrangement according to, grouping according to function, followed by burning, especially in the recycling process. Open burning with no environmental protection guideline at all. And that is an issue of concern. Next slide, please. Yeah, so this diagram, these pictures also depict that, but to your upper right, you see that that gentleman there is trying to protect himself by wearing a mask, but still the other parts of the body are not protected. Next slide, please. Yeah, so from this slide onwards, I present some studies that have been done, but still very preliminary. Study is ongoing, so I don't have most of the data to show, but to give you an idea that some work is going on. Next slide, please. So this shows the old Fadama sites, which is popularly known as Abublushi in Accra, the greater Accra region of Ghana, which is the capital. And it's sometimes referred to as the largest e-waste scrapyard in the world. And Accra has a population of about 4.2 million. And out of that, about 30 to 40,000 reside in the Abublushi area. And it's believed that about over 10,000 workers work in this yard, and about 1,500 of that working directly also and are associated with this yard on a regular basis. So our study looked, when you look at the map, you see the location of Accra indicated in red, and the red dots are where samples were taken. And the Abublushi yard is within the area at the middle with a brown background. And representative samples were taken for soil and sediments. Next slide, please. The same applies to the Kumasi yard, which is called the Dagomba line. It used to be along a railway line, which was operational in the past. And along this line, there's a water channel. And so the scrap dealers are dotted around this area. And the shaded area with green and then red dots, this is where all the major activities happen. And the red dots outside this area, places outside the immediate points of action to have an idea of the extent of pollution as you move away from the source. The Kumasi site is still a very young site and growing, and has about 1,000 workers there at the moment. Next slide, please. So what samples are taken from these sites, depending on what's available, soil, water, sediments, and in our lab, we typically use XRF or ICPOES for the analysis, and GCMS. And then works that have been done in the past were also reviewed, and it was evident that air, soil, and water bodies within these catchments, especially Accra, no work has been done in Kumasi yet reported. So in Accra have all been found to be very much contaminated, including clinical samples, urine and blood samples from workers were found to contain a wide range of heavy metals and polycyclic aromatic hydrocarbons, which are all toxic. And then it's known, it's reported in literature that these compounds and elements have the potential to cause organ failure, cardiovascular diseases, and even cancer in the long run. Our project has also confirmed these, and we've also extended to cover flame retardants, which have also been found, and these can cause hormonal changes, fertility problems, as well as cancer. Next slide, please. Yeah, in terms of interventions, the government of Ghana has, apart from being party to the global treaties that I indicated earlier, has also come up with these planned activities, which came out of, well, Where Are We in Africa project under the Basel Convention. And the planned activities are under the areas of conformity assessment, technology partnerships, financing mechanisms. Next slide, please. And then also the government has come up with the Hazardous and Electronic Waste Control and Management Act 917 of 2016. And then what is locally referred to as the eco tax has also been established. And then there's a plan to establish national recycling centers. There's one in Accra, as far as I know, but the plan is to extend it to cover other regions. And also in collaboration with the private sector and foreign partners, I'd like to mention the GIZ, which has established a recycling center at Agbogbloshie, and also a training school. And then other agencies on constant training of patrons of these yards on safety protocols and ways of handling, all with the aim of protecting themselves and the other people, as well as the environment, from the dangers associated with e-waste. Next slide, please. Now, in conclusion, I'd like to say that the e-waste trade in Ghana and other preferred destinations can be considered as a double-edged sword, in the sense that though as environmental scientists or as chemists, we will jump immediately and say that this is toxic, this is dangerous, it also offers a sense of livelihood and economic empowerment to those involved in the trade. Therefore, my questions for all of us to reflect on is that should governments of these affected jurisdictions leverage the trade in order to maximize the potential economic benefits, and also bearing in mind to minimize the associated risks, or should the trade be banned completely due to the risk involved? Next slide, please. So these are some references, and then I thank you very much for your attention.
Thank you, Marian. that has been very interesting and also disturbing. I mean, many of us may have seen these pictures, but it's always still shocking if you have not been at these places. And I think you already prepared the ground for the discussion at the end with your question for consideration, because it's a double-edged sword, and there are these pros and, let's call them pros and cons of the situation. And the first question already addresses or refers to this directly, because it says, how can we reduce e-waste? As long as the norm for electronics is planned obsolescence, that they break down after a certain time, or they have to be replaced because of a new operating system. And how can we, or should the focus be put on reducing the turnover of these gadgets and devices?
Yeah, so there's no single answer or one correct answer to this question, because as technology improves or advances, there is always the quest to acquire what is new on the market. So the average person, for example, uses a new cell phone every year. So I think the responsibility will lie on individuals, what I call responsible consumption, to know that ultimately it's not only policymakers and governments who control these things, but individuals also have a role to play in terms of how we utilize these e-gadgets. And if this information goes out there and trickles down to the youngest child possible who can perceive the implications of these, then collectively we will live responsibly. And if you have a cell phone, I'll use a simple example, cell phone. If you have a cell phone that can last you 5 years, you will use it till it gets to its really end, instead of changing on a daily basis. Otherwise, I don't see an end to this, really.
Yeah, thank you. I think, yeah. A different topic, for next question, covers or addresses the type of toxic effects. So what, in your studies in Ghana at the sites, were health effects recorded for the workers, and what were the major health issues in these people?
All right, so in our study, we haven't done that yet, except the typical reports of headaches, frequent headache and dizziness. But the other studies that have recorded more detailed health effects, like kidney diseases, respiratory diseases, and so on and so forth.
Mm-hmm. Good, thank you. And now again, as in the other talks, the question comes up of the science policy interface body and what it could offer, if anything, if you could offer policy solution to the problem. And yeah, if that's something that where you would see potential for improvement.
Yeah, the policies are already established. I think we have enough policies. What I personally think the issue is with implementation, strict enforcement of the laws, and also the need for Ghana and nations like Ghana to be very mindful of their borders and how penetrable they are or otherwise, so that these restrictions are very much tightened. Because from the overview I gave, it's very clear that most of these, especially the second-hand gadgets that end up here and elsewhere, follow unapproved routes, or even if approved at all, are packaged and labeled as something else. So if the ports will be very, very strict in checking and enforcing the laws that are already in existence, I think this will go down drastically.
Mm-hmm. Okay, I'm just digesting this. And now I will go back to the next question. Yeah, would a more modular way of building these devices help? I guess it would probably, that they could be taken apart more easily and without breaking them and without having to use force and heat and whatever.
Yeah, I agree. I agree that if there was a simple toolkit on how to dismantle electric gadgets to take out, yes, that will go a long way, because most of the time there is no real systematic way of this dismantling. It's just crush it as much as you can, apply as much heat as you can to find what you're looking for. Yeah, so I'll agree with that.
Okay, thank you. And another question that comes from another a developing country, and it says, how can developing countries try to apply advances on environmental regulation, such as risk assessment or chemical regulation, when we have many urgent topics, as you presented, caused by e-waste, for example? So this balance of urgent burning topics that need immediate attention and may not have to do with chemicals assessment, but as you said, enforcement, for example, versus developing more elaborate risk assessment schemes. How do you see that?
Yeah, I think, again, in terms of risk assessment, the literature is there to support. So even if the original information on how risk is determined, the knowledge is not generated in developing countries, the knowledge is available for implementation. And to a very large extent, scientists in these jurisdictions are very much aware of the risk associated with these actions. And that's why they talk about it. And that's why I'm talking about it today. But I think what is left to be done is the willpower, the political will for governments and the leaders of these jurisdictions to be very clear on what they want for their people. And I think the challenge here in most cases is the economics versus the science.
Yeah. Yeah, thank you. I think that's what we have to accept, and there's no easy way out. Let me take another look at there is a question about, yeah, again, the modular way of building phones.
Yes, I think that is very fantastic. It's a very good suggestion. I agree 100%. Yeah.
Yeah. Good. Then what else is coming in here? Do producers, I guess, of electronic devices have a large responsibility in design and marketing? That is.
I think that is outside my domain.
Yes,
outside
yeah.
my scope.
Yeah, probably yes, but I agree. And is the phase out of non-circular plastics, whatever that is, from products a step in the right direction?
The production of non-plastic materials, is that the question?
Of non-circular, I think that is plastics that cannot be recycled easily. That's what I understand. Would that be a step in the right direction? If that is phased out?
Yeah, but I have a feeling that could be more costly. Yeah, so, and if it's more costly, then again, the demand for the second-hand versions of those more costly will be high in developing countries.
Yeah.
Yeah.
Yeah, thank you. Yeah, so the last one I would like to take, it just came in, and you may also see it in the chat. It says, this may be outside the scope of this workshop, but is there a role for chemical industry to play in setting up new safe economic activities? If the main push for people to engage in dangerous e-waste processing activities is economic, could alternatives for livelihood help?
Yes, it will help. So I know there are interventions, especially in the main yard in Accra. The industry doesn't involve only men; it involves men, women, and children. So there's been some private sector interventions on training, especially hands-on technical skills training for some people, hairdressing, dressmaking, and so on and so forth, to move people out of the yard. So this is an ongoing process, and I believe if it is expanded and it is continued, with time, the numbers will go down, and hopefully the extent of harm will be reduced.
Good, thank you. I think that's a positive perhaps, if I may say so. And we may conclude here. Thank you again very much for the presentation and all the answers to the diverse questions. And
thank you too for having me.
Yeah, and we will come back to much of this, I guess, also in the panel discussion. And thank you again. With that, I would like to move on to the fourth speaker, final speaker, Sir Robert Tony Watson, who will speak about an assessment of options for strengthening the science policy interface at the international level for the sound management of chemicals and waste. And Robert Watson's career has included many important positions, and we're very glad that he is willing to speak here today. He has been the scientific advisor to the Office of Science and Technology of Policy at the White House, the chief scientist at the World Bank, the chief scientific advisor for the UK Department of Environment, Food and Rural Affairs, and strategic director for the Tyndall Centre, University of East Anglia in the UK. He has chaired, co-chaired or directed the WMO UNEP stratospheric ozone depletion assessments, global biodiversity assessment, Millennium Ecosystem Assessment, UK National Ecosystem Assessment, the Intergovernmental Panel on Climate Change, IPCC, the Intergovernmental Assessment of Agricultural, Scientific and Technology for Development, the Intergovernmental Science Policy Platform for Biodiversity and Ecosystem Services, IPBES, and UNEP's Making Peace with Nature. Awards he has received include a Knight's Bachelor, a Companion of the Order of St. Michael and St. George, Fellow of the Royal Society, Member of the American Philosophical Society, UN Champion of the World for Science and Innovation, and the Asahi Glass Blue Planet Prize. So with that, I would like to give the floor to you, Bob, and thank you again for your willingness to speak, and the floor is yours.
Thank you. Today, I would indeed like to talk about what are the options for strengthening the science policy interface for chemicals and waste. The next slide, please. This simply says that UNEP actually commissioned a paper to look at what were the options. Do we need a strengthened science policy interface or not? And Pierre Kohler from the US and I basically put a paper together for consideration of UNEA and of course all of the different governments in the world. One point I would like to make is if I look around all of the different issues that we face today, in every single successful science policy interface, scientific assessments play a critical role. It's absolutely crucial, whether it's at the national level or the international level, that policymakers have knowledge for evidence-based decision-making. And basically all a scientific assessment is, it's a critical evaluation of the information needed to guide decisions on often quite complex societal issues. And you'll see that when we talk in a minute. The next slide says, what was the motivation for putting together the International Ozone Assessments, the IPCC, and IPBES? Well, in every single case, governments around the world recognize that the issues of ozone depletion, climate change, loss of biodiversity, and the degradation of nature are global issues and affects everyone. And therefore, governments around the world, obviously working with other stakeholders, the private sector, NGOs, civil society, they needed to have an independent, and independent is a crucial word here, credible, transparent and open process that did provide authoritative state-of-the-art knowledge. Can you go back to the previous one? So they needed to have state-of-the-art knowledge, recognizing that scientific evidence is a necessary, but it is not a sufficient condition for informed evidence-based policy formulation and implementation. Too many scientists that believe that scientific evidence alone tells you what to do. It doesn't, but it is a very important input to decision-making at the national, global, and of course at the local level. Now, what did this require for these big issues of ozone, climate, and biodiversity? The processes needed to be intergovernmental. All countries, developed and developing countries, must effectively be involved, and the processes must be independent of any political bodies. They need to serve the conventions and the subsidiary bodies of the conventions, serve the United Nations system, but they must be completely independent of them. Another crucial issue is the assessments need to be comprehensive. They must be policy relevant, but they must not be policy prescriptive. The next slide then gives you a few more of the criteria. They need to be demand driven. They need to respond to the needs of decision makers, not just governments, private sector, civil society, etc. The processes must be owned by governments. And indeed, when we scope the ozone assessments, IPCC and IPBES, all assessments I've personally chaired or co-chaired, the scope itself must be co-designed by governments. What questions do they have? The scientific community that knows what some of the issues are, and other relevant actors. It clearly has to be credible, transparent, and legitimate. The processes themselves must be owned by all decision makers, which then means you need well-defined principles and procedures that discuss all elements of the assessment process. You need to develop a consensus view that's digestible, get rid of the jargon. What do we know? What is unknown? And what is uncertain? And what are the implications of uncertainty for policy formulation? There are some scientific uncertainties that are large, but they're actually not particularly relevant for policy formulation. There are other uncertainties that are quite small, are absolutely critical for informed policy formulation. It's absolutely clear one has to look at not only the environmental issues, but the social and economic implications of both action and inaction. What are the costs of acting to, say, decrease climate change, but what are the costs of inaction? And that is an absolutely critical thing. What do we know about action and inaction? It's quite obvious, and everyone focuses on technologies and policies when dealing with an issue like climate, biodiversity, chemicals, but behavior change at the individual level, at the community level, at the government level, and at the private sector level is also quite essential. So the social sciences are really very important at looking at the issue of behavior change. All documents must be heavily peer-reviewed by experts and governments, and indeed the IPCC and IPBES are reviewed multiple times. All of these documents tend to be too long, and therefore it's crucial to have a short summary for policymakers, typically 10 to 30 pages, that are less technical than the large international assessments that can be hundreds or even thousands of pages, but they must focus on the issues of most importance for policy formulation and in less technical language. The next slide. Clearly, to be credible, they have to be prepared by the world's best recognized experts. You need intellectual balance, natural, social scientists, humanities, technologies, economists. It needs to be geographically balanced. All countries must be involved and their experts must be involved. So developing economies in transition, and gender balance absolutely crucial. Clearly, when the experts are nominated, often by governments, they are, and of course other scientific organizations, the experts are there in their individual capacity. They're nominated and chosen within the open and transparent process. They do not represent the government. They do not represent an NGO. They do not represent an entity in the private sector. They're there in their individual capacity. Assessments need to be multi-thematic, multi-spatial, use a consistent theoretical framework, multi-temporal, look back in history, look where we are today, and use plausible future scenarios of where could an issue go in the future. And in fact, these plausible scenarios play a very, very important role in the assessments and in policy formulation. As we've already heard from a couple of the previous speakers, we need to link all environmental issues to development issues and, of course, to the policy process. How do these issues relate to the UN 17 Sustainable Development Goals? But let's be quite candid. Climate change, chemicals, ozone depletion, loss of nature, these are not just environmental issues. They're development issues, economic issues, security issues, social, moral, and ethical issues. And that's how we need to look at them. All of these issues, assessments must be evidence-based, not based on ideological value system, on issues that I've actually co-chaired, like genetic modification of crops. Ideology rears its head. When you talk about international trade, ideology. When you talk about sort of economic growth, ideology. All of the assessments must be evidence-based and not based on someone's independent or individual ideology value system. We need to recognize diverse worldviews and value systems, incredibly important for biodiversity, which brings you, we must utilize traditional, indigenous local knowledge and institutional knowledge as appropriate. We can't just focus on what I call institutionalized Western science. We must bring in indigenous knowledge as appropriate. The next slide. There are indeed multiple international assessments, and they've played an incredibly important role in policy formulation at the national and international. Stratospheric ozone. We have the international ozone assessments. They look at the science of the ozone system. They look at the impacts of the effects of reductions in stratospheric ozone, and they look at technological options to reduce the threat to stratospheric ozone and the economic cost. These assessments underpin the Stratospheric Ozone Convention and its Montreal Protocol and the amendments and adjustments. We have the IPCC, the Intergovernmental Panel on Climate Change, playing a crucial role in feeding in information to the UNFCCC. And in, of course, 2 weeks' time, we'll have the meeting in Glasgow, looking at how we can strengthen the actions to meet the Paris climate targets. We have the Intergovernmental Science Policy Platform for Biodiversity and Ecosystem Services. This feeds in to the United Nations Convention on Biodiversity and a half dozen other related biodiversity conventions, such as Ramsar, CITES, CMS. We then, of course, have the UNEP, Global Environmental Output, key input to the workings of UNEP and UNEA, but also looked at very carefully by governments and the private sector around the world. We have the CBD, Global Biodiversity Outlook, directly of relevance to the UN CBD. We then have the International Resource Panel, which is responsive to UNEP, but plays a key role in thinking through all of the issues on resources, whether it's chemicals, whether it's ozone depletion, whether it's climate change or biodiversity. And then, of course, most relevant for this is we have the UNEP Chemicals Outlook. And of course, I forgot to put on the side the Waste Outlook that respond to UNEP and UNEA. And we can learn lessons from all of these assessments. The next slide, please. This shows you the success story, the ultimate success story, in my opinion, of stratospheric ozone. On the very top, it's just a timeline of when scientific advances were made. So in other words, in 1974, we had the theory that CFCs would destroy ozone. In 1985, we discovered the ozone hole in Antarctica. And in 1987, we actually proved what was causing the ozone hole in Antarctica. Between 1985 and 1989, lots of good modeling to describe the chemical, physical, radiative processes controlling ozone, etc. The next level below in yellow, these are all of the international assessments that have been done on stratospheric ozone. I was involved from 1981 as the chair all the way through to 2014, but they still continue today. And then what you see in blue slightly below it is, how did policy respond at the international level? So we had the convention in 1985, the protocol originally in 1987, and then amendments and adjustments. And at the bottom, you see what happens to the chlorine loading in the atmosphere. And as you can see, after we had the Montreal Protocol with strong limitations in the amendments and adjustments, the emissions of chlorine and bromine decreased and the atmospheric burden decreased over time. This is a beautiful example of scientific knowledge, assessments, policy, and how the environment responded. The next slide. So what guided the study that Pia and I looked at? So we said, are the existing interfaces adequate, or do we need a new process? What would be the institutional arrangements to be most effective if we have a new process? What are the key elements of the rules of procedure? Who does it report to? Who makes the key decisions? What are the elements or the key elements of a process? Who should fund it? Who should provide a secretariat? And on the output, should the platform be global or regional? What sort of information? Is it only journal articles, or does it include grey literature? Does it talk about policy options? Does it talk about guidelines? Should the platform, how should you measure the success of a platform? Can you go back again? How do you measure the success of a platform? Who should prepare the assessments? How would you review it? And what are the different functions? Is it just to assess knowledge, or does it do capacity building? Does it do policy formulation? Next slide now. We came up with 3 options. We were told not to come up with a preference. So we had an option A, an independent platform like IPCC or IPBES, or option B, institutionalizing the current chemicals and waste management process. And the third is more along the lines of the international ozone assessments, where you have subsidiary panels with specialized task force for particular issues. The next slide is ours, basically. So we now came to some answers. Now, these are my personal view. The actual document is much more neutral. So are the interfaces adequate? No. I believe we need a new IPCC IPBES type process, or one along the lines of the international agricultural process. The difference between the two is in the plenary and the bureau, only governments make decisions, whereas in the agricultural sector, the bureau also had members from the private sector, the NGOs, from consumers, and many others. So it was a much more multi-sectoral, multi-stakeholder bureau. What institutional arrangements? Again, similar to IPBES. Can we go back one slide again? Yeah. What institutional arrangements? Well, I would argue again, IPCC, IPBES. Who will it report to? And this is critical. I would suggest a combination of UNEA because of the environmental issues, and World Health Organization because of the health issues involved with chemicals. Who makes key decisions? Clearly the plenary, made up predominantly of governments. What are some of the key issues? How do you scope an assessment? How do you select experts? Who approves it, etc.? How do you fund it? Blind trust funds are the way to go. Governments will be the dominant funder, but there's no reason, if you have well-defined criteria and contributions, that you can actually accept money from philanthropic organizations and the private sector. I would suggest UNEP could provide the secretariat, but it could be a split secretariat between UNEP and World Health Organizations. I would argue on outputs, it would address both global and regional spatial dimensions. You would certainly measure the impact of, is it influencing or not the science policy interface. You would certainly use journal material, openly available grey material, and indigenous and local knowledge. I've already said it should be prepared by experts in their individual capacity. The external view must involve governments, but also all experts with appropriate knowledge, basically. Clearly on functions, the primary function would be to assess knowledge that is policy relevant, but it could also go beyond that and do capacity building like IPBES does, but it comes with financial costs. And the next slide, which I believe is my last slide. So, issues to be considered. Should a governance structure for chemicals and waste be limited to governments, a la IPCC or IPBES, or should the private sector and NGOs have a role as members of the Bureau? In an intergovernmental process, governments would always make the decisions, but should you embed NGOs and the private sector in something like a Bureau, a major decision that has to be met. I personally like the agricultural assessment that I chair, that I directed, because it brought all stakeholders to the table right at the beginning. As both chemicals are a major factor in both climate change and biodiversity, as well as obviously pollution control, any strengthening interface on science and policy for chemicals and waste must have maximum collaboration, not duplication, with IPCC and IPBES. Clearly, any new interface must have the status, authority, and credibility to attract the world's best scientific talent from the academic community and other communities, a la IPCC and IPBES. Should a strengthened science and policy interface have extra roles like capacity building? The answer, in my opinion, can be very, very helpful, but there are cost implications. But are there issues that are burning? So one wouldn't do just a big global assessment of all of the issues on chemicals and waste, but is there an issue where you can start right at the beginning in a narrow way for the economics, for example, of chemicals and waste? Because the Stern report for climate and the recent Dasgupta report for biodiversity have been very, very influential about thinking about the economic and financial issues associated with climate and biodiversity. Is such a thing needed for chemicals and waste? And the very last slide is the conclusion. And I've said, very last slide, I would argue there is an urgent need to strengthen the science and policy interface at all levels, so you can promote science-based action at local, national, regional, and global scale on the sound management of chemicals and waste. It must be independent, demand-driven, inclusive of all relevant stakeholders, co-designed and co-produced by governments, academia, private sector, be policy relevant, not policy prescriptive, must ensure that the expertise comes from both developed and developing countries, as well as from indigenous communities, taking into account local knowledge and gender considerations, and maximum collaboration with both IPCC and IPBES. Thank you.
Thank you very much, Bob. That has been a rich overview and summary of many aspects and requirements and ideas. Thank you. We have a couple of minutes left for discussion, and I have some questions I would just kind of throw at you now. One is about the question of evidence-based assessments. And if the assessments have to be evidence-based, what about emerging risks, risks for which there is not yet a lot of evidence there in the real world out there, but it's still possible to assume or to already predict that they may come?
Yes, I mean, I'd still say that would still be evidence. I mean, Björn basically talked about how you can actually group chemicals, basically predictive toxicology and grouping different chemicals. And so here, effectively, you can potentially, if you need to, have regulations on a particular chemical where you may not have always studied that particular chemical in depth. But these international assessments could also be used for looking at emerging issues. In other words, you could put a team together really quickly. Now, there's ways to do it, and there are challenges, because if you do something quickly, it's hard to do 2 levels of really thorough peer review. But very recently, IPBES did a really nice study on the COVID-19 pandemic, and they put a workshop together. Didn't quite have the same status as a fully fledged assessment, but the workshop brought together about 50 experts from all around the world to look at all of the issues to do with pandemics. It wasn't just COVID-19, it was the general issue of pandemics. How can you get ahead and prevent pandemics? And that was really useful. So if you had an emerging issue, I would argue an entity could put together a workshop at very, very short time space, look to see what evidence there is, what is known, but what are the evidence gaps, and what research would you need to fill those evidence gaps?
Good. Okay, I think that gives an indication of what you mean and what could be done, and that would also create space for different types of evidence, I may say.
Yeah, exactly.
Yeah. Then there are only 2 questions that refer to the let's say the successes or the effects of the intergovernmental panels. You mentioned the ozone depletion case that was very successful, but then there's now the question also what has been accomplished by IPCC that would not have been accomplished without it, or similarly also with IPBES.
In my opinion, it's personal opinion, of course, without the IPCC, we would not have the UNFCCC, in other words, the Climate Convention. We wouldn't have had the Kyoto, we would not have had the Kyoto Protocol, and we certainly wouldn't have the Paris Agreement. Now, has it been fully successful? Well, obviously, science, as I said earlier, is only one input for informed decision making. All governments of the world have signed off on IPCC and the conclusions. Therefore, there is less argument about the knowledge base. There's more argument about, well, can we do it? What are the challenges nationally? What are the costs? How will it affect the labour force in a different country, etc.? There are still some governments who still argue climate change is overblown, is a hoax. President Trump, when he was president of the United States, argued against climate change. But the vast majority of governments and the private sector now all recognise that climate change is serious. And what IPCC does, it gives a common basis of knowledge for informed decision making. Similarly, IPBES now is playing the same role on biodiversity. My argument would be, if we didn't have IPCC, we would have to invent it. I think it's played a crucial role pointing out what is happening to the climate system, what are the risks of a climate change, and what are the technological, economic, and behavioral options to address climate change, both mitigation and adaptation.
Okay. Thank you, because that is a key question, of course, also for the upcoming discussion about a possible new intergovernmental body. What has it been that the other bodies have accomplished that would not have happened without them? And I guess we may come back to that question also in the panel discussion. I have seen some questions here that, but they are all quite specific. For example, as a last one, do you have a suggestion for a burning issue requiring immediate assessment?
I'm not a chemicals expert, to be honest. I would argue I might be an expert on how to conduct and chair international assessments. I would like to I think other people here are much more expert. The issue of microplastics is clearly one that is a real issue. It's really affecting biodiversity. What are the issues on human health as well? And so to me, as a non-expert on chemicals, issues like microplastics would be one. And the other one is, do we fully understand all of the relevant issues on the economics and the financing of the chemicals industry? One thing I never said, one very big difference between the chemical and waste issue and climate and biodiversity is much of the knowledge on the chemicals is proprietary knowledge held by the private sector. And so if you're going to do an international assessment, to use that knowledge, it has to be open and transparent. And so there is a really big difference between the climate knowledge and biodiversity knowledge, which is often held in government organizations, the academic community, NGOs. A far bigger part of the chemicals knowledge is in the private sector. And that needs to be given real serious consideration when you structure the governance issues.
Yeah, thank you. We are at the end, but I have one that I like that is really important probably, and this is, are there precautionary tales, or what could be wrong? What is the warning that you would give for the establishment of a new panel?
It must be open and transparent. It mustn't be captured by political interest or vested interest, either governments who all have their vested interest, or by the private sector that has it. So setting up the principles and procedures of how you scope a document, how you prepare the document, how you peer review it, how you approve it. All of the issues of the process must be very open and transparent. You need a panel to look at conflicts of interest to make sure that none of the participants have a known conflict of interest. So you have to minimize. If you accept funding from multiple sources, it is absolutely crucial it goes into a blind trust fund that whoever provides the money does not independently control the process. All decisions need to be made in plenary, which is the role of the governments in an intergovernmental organization. Others can give advice. The NGOs, the science community, the business community can suggest topics for consideration, etc. But at the end of the day, it must be a plenary with very well defined rules of procedure, avoiding all conflicts of interest.
Yeah, thank you. That makes perfect sense. And I think it's a very good last word on this part. Thank you again, Bob, for the talk and all these answers to the questions. And then enter the panel discussion. And then my colleague Miriam Diamond will take over and moderate the panel discussion.
Good morning, good afternoon, good evening, depending on where you are. My name is Miriam Diamond. I'm the vice chair of the International Panel on Chemical Pollution. I'm also a professor at the University of Toronto. So I'd like to welcome all our participants and again, thank our speakers for those very invigorating, thoughtful, and at times provocative comments that we heard. We're now going to have a panel discussion. So I'm very pleased that we have that in addition to our 4 speakers, we have 2 additional speakers on our panel. So I will introduce Felix Wertli and Zhanyun Wang to our panel. Thank you. So I'm going to briefly introduce them. Felix and Zhanyun will provide some introductory comments. Then we'll open up the panel discussion for all 6 panelists. So starting with Felix, he's the head of the Global Affairs section at the Swiss Federal Office for the Environment. And prior to that, Felix served as a counselor for trade and development at the Permanent Mission of Switzerland to the World Trade Organization. He has also worked as program officer for development, NGOs, and managed multiple projects, particularly in Kenya and Haiti, supporting communities to develop and implement projects for sustainable development. Felix holds a master's degree in development studies from the Swiss Federal Institute of Technology in Zurich, otherwise known as ETH, and a degree in geography from the University of Geneva. Felix, I open the floor to you. And Felix, I believe you have to unmute.
Thank you very much.
Of course.
For that. Yes.
No, that's just the most commonly said phrase since the pandemic started. So thank you.
So good. I try again.
Perfect.
Thank you very much for inviting me for this panel, and thank you very much for all the input so far. It has been really an interesting time, and I can really also, I think, link to previous interventions. So I think the reason why I have been invited today is because Switzerland has announced to table a resolution at the next UN Environment Assembly, February 2022, to establish Intergovernmental Panel on chemicals, waste and pollution. Just let me go one step back before I go very concretely on the panel, with where we are coming from. I know in the international scene, we have the SDGs, we have the target that we wanted to achieve by 2020, the sound mention of chemicals and waste. It's clear that we have not achieved this, and the global chemicals outlooks gave important insights why. And when we take different elements about it, we can see that on the one hand, we have still gaps in knowledge and information about the effects on humans and the environment of many hazardous substances. We have also the problem that information that we have is insufficiently disseminated or not well accessible for all. And the third element is that in many areas where we have the knowledge and where the information is accessible, the action is still nevertheless insufficient. In our view, all those elements, all those main challenges are related to the field of science and policy. UNEA 4 recognized that science is central to achieve successful chemicals and waste actions. They also confirmed that science is needed to set priorities for policymakers, and that we have to promote it at all levels, and that the interface on science policy has to be strengthened. I think over the last 2 years, it has been a lot of discussions going on. There's a growing recognition of the importance. We have seen that the stakeholders of ICCM5 have acknowledged that. We have the academia, the science community like IPCP that have done a lot too on this field and also enhanced the call to UNEA to take action. Or most recently, the special rapporteur on toxic and human rights has also drawn the importance of to strengthen SPI. Perhaps we can put on the next slide where I explain what are the key elements of our resolution. So first and most important for sure is that we have the objective to establish such an intergovernmental panel. Then we would like to agree at UNEA that the panel could support international agencies. So that means mainly the UN agencies. Instruments could be, for example, the ICAN process, the post-2020 process for the sound mention of chemicals and waste. Sorry, also I forgot about the international agencies. For sure, so we mean the MEAs, so the environmental agreements, the conventions we have. It should also be a support of countries. You have heard already that some of the countries don't have enough resources to establish all analysis by themselves. Such a plan can be very helpful. And for sure, it's also be helpful for the private sector. We have described the support as authoritative, independent, credible, inclusive, policy relevant. I think Bob Watts has already explained a lot about those concepts. I think it's also a signal that we strive for the best and highest quality in such a panel. I think also explained by others, we need this kind of highest quality that the panel is fully recognized and can act as it should. The benefits of the device, I think it's also important to explain, and also to convince people, is for sure that we want to enable more timely action to minimize and prevent adverse effects of pollution and assess potential solutions. It should help to prioritize so that we can prioritize the use of resources. And it should also help for guiding scientists to conduct timely research to support policymaking. About the key function we have outlined 3. So first of all, it's a horizon scanning. So this systematic examination of information to identify potential threat, risk, emerging issues, but also opportunities. Among this also, we have this identification of issues of concern, and then to provide evidence-based options or solutions how to address them. The second one, carrying out assessments. I think Bob Watson has explained that very well, what assessments are, what are the key criteria to have good assessments. I think I can subscribe to that. That also is a hint that we will not go to basic research. It's really about to assemble existing information and make them a report that is policy relevant for policymakers. And then the third element, you could also summarize that of the communication. I think one example, if you talk to academia, very important that here we have the chance to ensure the communication between scientists and policymakers, that we are able to also inform the larger public, so to increase the visibility of the issues and inform people about it. The next point would be that we want to agree that the panel should be autonomous and intergovernmental. I think very key is intergovernmental. For us, it's important that the governments are in the driver's seat. This is coming from the thinking that it's about the governments that have to decide what are most burning questions. This can be fed in also by NGOs, by academia, by private sector to define what are those questions. But to be sure that the governments will use the findings, it's also important that they can ask the questions. And then the last point on this slide is to establish an open-ended working group. That means we would like to establish a negotiation committee that will work to establish such a panel. Next slide. Now, when you talk about the panel, some very relevant concepts or key elements of it. So it has to be policy relevant without being policy prescriptive. I think this has been discussed also before. It shows now that governments have to benefit, perhaps also others to benefit from the information to apply it. But it's up to them also to decide to what extent and how to apply it best. Often also there are perhaps different scenarios, different options. So they have to be useful for them in developing legislation and so on, guidance, but it can't be policy prescriptive. Second point, it has to be interdisciplinary. I think that we have heard also a lot. It has to include economists, social studies and so on, about behavioral elements, to really also to discuss how to bring in the change, how to adjust best, how to adapt best. And also for sure, geographical, regional and gender balance. You have to be sure that all kind of perspectives are fully reflected in the study, in the findings, because also the solutions have to be important, helpful for all the whole globe, the whole world, but also for all kind of groups and social groups. It has to be authority, credibility, legitimacy, and transparency. I think here again, we go to these elements. What are the key criteria to ensure a very good quality? And because a panel without legitimacy is not the one that will be used, the findings. Without transparency, there will be mistrust, it's not possible. So we have to ensure that we make how to translate those kind of key principles into action. That will be one of the things we have to discuss further. The next point is to complement and not duplicate the work of other agencies and scientific bodies. Here, for example, when we look at the chemicals and waste cluster, we have important actors. We have not only one UN agency working on it, we have different ones. So we have UNEP, WHO, ILO, and so on. So we think we have to draw from their experience all, we have to use their knowledge to include them. And then we have specific scientific bodies, for example, under the MEAs, the conventions. And those scientific bodies, it's not the idea to replace them, because they have a specific task for specific conventions. For example, they discuss if substances have to be listed in the annex of a convention. So this is not to be replaced. They will remain, they will be relevant, have to go on with doing their work. It's something additional to bring the broader picture, the overarching elements. The next point is to address conflicts of interest and to manage confidential information. I think also here we can learn from others like IPCC. And then also, as Bob Watson has said, for sure we have to look specifically also what are key elements in the chemicals and waste sector, what is different perhaps from other sectors, to be sure that we can take that into account. Because when we link this also to the question of transparency, legitimacy, it is clear if we are not able to address them properly, then we'll have a problem. And I think also one point on this of conflict of interest is also to think when we say we want a report that is policy relevant, that means also we have a summary for policymakers. So we have And often those summaries are going negotiated between governments. It also means there's a question how to ensure the integrity of the science so that we only work with those findings from the report and not going back to challenge the science that has been found. The last element, it has to be flexible and cost effective. I think always funding is key to have a good and sound funding, and to be flexible also means that we have to be able to adjust to the demands, to the requests, and also in a way how to interact with other actors who already have information. The last slide, please. Then also perhaps a few elements on what the Open Working Group has to work on. So they would have to translate all the requests and these key elements that we have defined in the resolution into action to establish the panel. For sure, one question is institutional design. So how should it work? How should it function? So we have to decide how to establish the work program. It could be there are many requests, many questions, or how to bundle them, how them to bring together, how to prioritize. Then the third point, we have to identify and work with experts and international policy-making actors. So also we're going back to this question of how to avoid conflict of interests, how to reach out to have the best scientists, how to reach out to networks that exists, also the private sector, to academia, how to use them. The next point is how to agree on reports. So also going back to this point that we will have kind of summary for policymakers. Often those summaries are negotiated. And there we have to be sure that we are not going to challenge or undermine the findings of the science, but to use them to develop good options. And then the last point, I bundled on administrative issues. That's a bit about the functioning of such a panel. So how are the rules of procedure, the budget, funding, and so on. Yes, so thank you very much. It's a few points from my side. And as mentioned, they hopefully will be negotiated next February at UNEA. And this is brought forward by Switzerland, but we are supported by already by a number of countries, and I think this alliance of support that is growing over the coming weeks. Thank you.
Felix, thank you very much for your comments, and it's very exciting that you shared with us the initiative that will come from the Swiss government to UNEA 5.2 in February. So next, we will entertain questions for Felix and all other panelists after we hear from Zhanyun Wang. Well, I've known Zhanyun for quite a while, and it's really a pleasure to introduce Zhanyun, who's a member of the board of the IPCP. And I have to tell you that Zhanyun is really the driving force behind not only the science article, but really this workshop that we're sharing with you today. So Zhanyun is a lot of the brains and energy behind this initiative. So Zhanyun led the development of the science article. He's an environmental chemist by training. His research focuses primarily on understanding the life cycles and risks of various anthropogenic chemicals in the technosphere and natural environment. He's also very interested in exploring novel and pragmatic approaches to advancing sound chemicals management, enabling a sustainable circular economy, and strengthening the science policy interface on chemicals and waste. Zhanyun has authored nearly 50 peer-reviewed articles. Well, for those who are old, that may not sound like much, but the thing is that he's done this in probably less than 10 years. So I find that totally amazing. And they're high impact articles. In addition, he has led or co-authored more than 10 technical reports published by the OECD, UNEP, Nordic Council, Swiss Federal Office for the Environment, Norwegian Environmental Agency, and other government institutions. Zhanyun, your turn.
Yeah, many thanks, Marian, for your very kind words. Yeah, well, also like to first thank all the previous speakers for their very valuable food for thought. I think it was really a great discussion today. We'll also like to thank the Swiss government and other countries for taking the step to bring this global science policy body on chemicals and waste into the global political discussion. As also pointed out by our science article early this year, my colleagues and I agree very much to the proposal of this establishing such a global science policy body. We do believe that such a body can be a key tool that Björn has just mentioned about to connect the regulatory, the policymaker side, and also the scientific side. So such a body will not only help to bring the state-of-the-art science to policymakers to identify issues with emerging evidence of concern and developing innovative solutions, but it will also help to engage and coordinate the scientific community to conduct the timely research to support policymakers and business leaders' action to solve the global threat of chemical pollution. Yeah, I like all the previous speakers have brought many really good points for establishing such a body. I don't want to repeat more, but I would like to emphasize like 3 points for consideration at UNEA 5.2 negotiation in designing such a body or initiating a process to design such a body. First, this body needs to be forward-looking and action-oriented. So on many legacy issues such as lead, cadmium, mercury, pesticides, scientific evidence has been well documented and policymakers have recognized the need to take action. So a global science policy body can focus on evaluating the effectiveness of current and future initiatives to guide action towards resolving these issues in an effective and efficient manner. And also, as Bob said, there could also be economic and assessment about the economic, social economic impacts, implications of inactions and action to promote more actions from the policymaker side. At the same time, main task of such a body will be to collect and synthesize existing scientific evidence that is scattered in the public domain and behind high paywalls, identify potential issues of concern, and make them visible to policymakers to promote early intervention. Second, this body needs to be inclusive, but yet protected from conflict of interest. The inclusiveness recognizes that such a body needs to engage and involve a wide range of disciplines, including those that have not traditionally associated with chemical pollution, such as chemistry and chemical engineering, development cooperation, informatics, and social sciences. Yeah, we very much welcome the proposal by Switzerland and also the suggestions by Bob that such a body jointly supported by UNEP and WHO. This will be a very good starting point. It will be good to also see wider participation by other intergovernmental organizations. The inclusiveness also recognizes that such a body needs to engage and involve scientists from both developed and developing countries to support developments developing a socially inclusive and just global policy on chemical pollution. At the same time, such a body should have a strict conflict of interest policy to protect the organization and its outcomes from deniers and doubt creators, as we have seen in the climate field. So IPCC and IPBES have set up such conflict of interest policy, and we can definitely learn from them. Third, this body needs to be agile and flexible. Chemical pollution is very broad, and different issues may require different expertise. And many new evidence is being generated, raising new issues. So such a body would need to have a flexible structure to address different issues such as plastic pollution and endocrine disrupting chemicals and many others as they rise and in a very timely manner. And like Bob also has provided some really good, interesting examples of IPBES addressing the impacts of pandemic. So I think this was all things that we can learn from. So yeah, slowly I would like to close my intervention. Like, it is not the first time that the international community has established a global science policy body. And we do have seen the huge benefits of two most famous ones, IPCC and IPBES, as also Bob pointed out. So it is really time to take the step forward in order to solve the global threat of chemical pollution. We have learned a lot from IPCC, IPBES, and other science policy bodies. So I trust that the international community is able to use the lessons learned from them and design a global science policy body on chemicals and waste that is forward-looking and action-oriented, that is inclusive, but yet protected from conflict of interest, and that is agile and flexible, tailored to the needs. I very much look forward to further discussion with my fellow panel members. Thank you so much.
Thank you, Zhanyun, and thanks again, Felix. So now I'd like to invite the panel members to come from behind the screen. Thank you. And I'll just give a very brief recap, which I'm sure will not do justice to each speaker's very interesting and rich presentation. We started the workshop with Satoru Morishita, who is the former Vice Minister for Global Environmental Affairs of the Ministry of the Environment in Japan. Satoru really emphasized the importance of sustainability and moving forward with managing chemicals and waste. It's really the need to promote effective solutions that provide co-benefits, because it's the co-benefits really that enable and that provide the effectiveness of solutions. Satoru talked about co-benefits coming from both the manufacturing sector and from nature-related systems. Satoru offered a series of recommendations for global action, and amongst those is the importance of sharing knowledge. Our next speaker was Björn Hansen, the Executive Director of the European Chemicals Agency. And Björn really gave us a perspective from a regulatory agency, because regulatory agencies have a particular and very important role to play in the entire ecosystem of chemicals management, chemicals waste. The regulatory agencies have levers that can be exerted. So Björn talked about policy decisions that can drive the reduction really of impacts and promote safety in terms of chemicals and waste management. And within the context of what can and cannot be accomplished through market forces. Björn emphasized that policy decisions must be underpinned by credible tools that are both predictive and preventative in order to ultimately promote safety, circularity, and energy efficiency. So both Satoru and Björn talked about the leveraging the co-benefits of recognizing combined threats, for example, of climate change, greenhouse gas emissions, when we consider chemicals management. Our third speaker was Marian Nkansah, who is an associate professor at Kwame Nkrumah University of Science and Technology in Kumasi, Ghana. Marian focused her comments particularly on e-waste. And I would just like to say, because coincidentally, I just gave a lecture on e-waste to my second year class yesterday. And it always astonishes me that the estimated amount of e-waste produced annually in the globe is more than 10% of the entire body mass of every person on the planet. The e-waste produced every year is more than 10% of the mass of all the bodies on the planet. Now, Marianne talked specifically about issues that affect Ghana because such a high proportion, anywhere from 60 to 90% of e-waste that is supposed to be managed properly according to legislation that affects a large percentage of the global population, and yet ends up in lower income countries where it's very poorly managed. But Marianne really talked about the importance, not just of having instruments, but it's of the enforcement of existing policies and regulations. And Marianne also emphasized that we make choices, and our choices often, unfortunately, pit or pose economic priorities versus environmental protection, which includes the safety of both humans and the ecosystem. And finally, we heard from Bob Watson, Bob, I can't even say all the things that you've done, so I think I'm going to be very brief here, but you're the former chair of the Montreal Protocol Assessment Panel, the IPCC and IPBES. So Bob, you talked about issues that to really clarify what's needed to move forward with a science policy interface for chemicals and waste. And really many of these precepts or guiding principles were reiterated and stated by Felix as well. But Bob, you started with stressing the importance of the need and important impact of scientific assessments that must be comprehensive, independent, credible, authoritative, and transparent. And you've emphasized that they have to be policy relevant, but not policy prescriptive, because it's up to an intergovernmental science policy interface body with buy-in from all governments to actually make those policies and decisions, which require the buy-in of all governments. So those were the main points that I took from your talks. But now we're going to open up the panel for questions, and I'm going to start with something easy if I can find where these questions are. And that is, first of all, what excites you about building a science policy interface for chemicals and waste? So I'm actually going to start with Marianne because, did we lose Marianne already? Because I know that Marianne had to leave an hour early. Okay, so I believe we've lost Marianne, and I'm very sorry about that because there are so many important questions that affect the global south. So I'm going to start with Satoru for this question. What excites you about building a science policy interface body for chemicals and waste?
Thank you, Marianne. And as I mentioned in my presentation, there is something missing and something need to be done to enhance chemicals and waste management. And after hearing today's discussions, I have a feeling that, what has been discussed is very important. For example, it should be the new initiatives should be demand-driven or transparent or inclusive and overarching. Those kind of the elements are really important for starting new actions. Having said that, I think, it's very important to have such kind of the platform or the interlinkages between the different sectors, policymakers and scientist communities, and which may be able to create a new perspective, new trend, which is currently missing. So I would like to encourage the scientific communities to elaborate on that. In particular, what is the missing part of the current setup, and what is the top priorities, or where do we have to pay more attention to that? And that such kind of discussion need to be further made, and the outcome should be clearly presented in front of the policymakers. Then something will take action. Thank you.
Thank you very much. I'd now like to read Marianne's answer, because unfortunately Marianne had to drop off. And she commented that the components of chemicals and waste are ubiquitous and restricted by geographic boundaries. It's therefore refreshing if the whole world takes responsibility to combat the challenges and not just a select few. Next, I'd like to turn that question to Björn. What excites you about a global science policy body on chemicals and waste?
Thanks a lot. I think I'm just aligned with what you've already heard. To me, the excitement lays really in that it is a clear indication that something is missing in order to do more. And it's the recognition that we need to do more in order to meet the Sustainable Development Goals, and the recognition that chemicals plays a very important part. I would say it's a prerequisite to meet the Sustainable Development Goals that we get the right action on chemicals. I'll stop there. We can talk about what the right action is. I illustrated in my talk what I thought about it, but I think that's for me the excitement. We're coming together, recognizing there's an even bigger challenge than we thought some years ago.
Great, thank you, Björn. And Bob?
Very, very straightforward. It will provide the evidence base for informed decision making at the national, international level. It will be able to link the chemicals agenda and waste agenda to the other environmental issues like climate change, biodiversity, and the development issues like food, water security, human health. It'll involve the best experts in the world, and it will involve all relevant stakeholders. I'll give you an example. Before we had IPBES, which was founded in 2012, the only big global issue anyone was talking about was climate change. And even by about 2020, a year or so ago, the dominant issue, or 2019, the dominant issue was climate change. The IPBES global assessment, backed up by our regional assessments and others, have put biodiversity on the map. Biodiversity was not on the map in the same level of climate change 2 years ago. It had a convention, yes, but it was not on the map in the same way. Today, people are not only talking about climate change, they're talking about biodiversity. They're talking about the coupling of biodiversity and climate change. The sort of science policy interface we can see now or foresee for chemicals will do the same for chemicals. It will be talked about. It will be linked to the other big environmental and development issues. It's an incredible opportunity if governments do not become penny pinching and say, boy, such a mechanism is too expensive.
Thanks, Bob. And it's easy to see how you've been a very effective cheerleader for a number of science policy interface bodies. Next, Felix, on the question of what excites you about a science policy interface body. And I hope you will be excited, of course, because you're bringing this forward to UNEA.
I have to say I'm very much excited and very much committed. I think good arguments have been said already. I really believe also that the science policy panel is key, that we can do more and we can do better. Because we can do more by gaining visibility, by gaining the important topics, to outline them, to show them and so on, and also do better by having good advice. from the side of Switzerland, we have good experience with science policy panels. The IPCC report on the 1.5 degree, for example, that led that the Swiss government decided to adjust to increase the target. So it was a concrete example how a report can lead to action. We have also heard from Mr. Satoru the idea of co-benefits. When we look at the current discussion, it's always IPCC, IPBES. The chemicals waste cluster is not there. GCO is not having the same standing, the same level to create those kind of interactions together. Another example, we have the UNEP midterm strategy. UNEP has now 3 action pillars. One is climate change, one is nature biodiversity, the third one, pollution, chemicals, waste. First pillar, IPCC, second pillar, IPBES, third one, no, we don't have it. So already from this institutional setting, we need something, and I'm deeply convinced that we can raise it. And just one remark about the funding. I challenge you to think about how much is the budget of IPCC. And I think most of you have thought now it must be more than 10, 12 millions a year. To my knowledge, it's about $6 to $8 million a year. Just imagine the impact we are achieving with this panel. How much political influence, how much bring we forward this agenda? I believe that the chemicals and waste panel could be smaller, more cost effective at the very beginning, for sure. And we will get so much out of it because we'll also increase the funding, we'll raise visibility. It's also a key issue. Thank you.
Felix, thank you very much for those remarks and also for putting into the context the funding, which is often raised as an impediment to developing a new body. And finally, on this question of what excites you, Zhanyun?
Yeah, thank you. I think my points are quite similar to the previous speakers. I think it is really a brilliant opportunity really to bring this, the chemical pollution and the urgency of the chemical pollution into the discussion and to the policymakers around the world. And I think also it is really also a very unique opportunity to really engage the wide scientific community. It's kind of like to engage the different disciplines to work together to have the innovative solutions from the upstream to develop new chemicals, new processes that would replace the hazardous ones, and also to engage the development, the scientists in developed world also to work with the scientists in developing countries to also bring the knowledge, technology there to also like learn from them and to develop better, also to help them also to the developing countries to assist with the implementation. And I think the third point that I would like to raise is that again, it's a race related to the public awareness and also the public profile of chemicals and waste is that such a body can also give a signal to universities that we need to keep the disciplines of environmental chemistry, ecotoxicology, etc., to also embed it in the curriculum, and also so that we can also train more like future scientists, business leaders, policymakers, so that they will continue to solve the issue. I think it has been seen in Europe, there have been some decline of such like safety, sustainability related studies in many universities in Europe. So I think such a body will help to also to attract more future generations to work on these issues. Thank you.
Thank you, Zhanyun. And of course, coming from a university, I understand the importance of building capacity within universities because at least I hear the giant draw from lucrative professions that take away the best and the brightest from the ranks of our students dedicated to environmental protection. But your second response, Zhanyun, is a very good segue about the needs of the Global South to the next question. And I'll just say for the next question, I'm going to read Marianne's answer, and then I'm going to go in reverse order. for the panelists, starting with Zhanyun, just so you know when I'll be asking you. So the next question is, what are the needs and conditions of the global south that must be considered in establishing a global science policy body? So Marianne responded that representatives from scientists, policymakers, and politicians from the global south should be present at the table from the point of view of brainstorming to the point or of formulation, so that they are really an essential part and have collective ownership of the body and its deliberations. Issues of political will, access to information, and appropriate technology and funding for research all need to be considered. So those were Marianne's comments. And now I'm going to go in reverse orders to ask this question about the needs of the global south, starting with Zhanyun.
I think that's a really important question. Just talking about some of my recent experience in reviewing the kind of the policy needs for scientific evidence under the Basel, Rotterdam, and Stockholm conventions. So I also just very recently, I think there was at the Chemicals Review Committee of the Stockholm Convention, they were reviewing the notifications of banning like 7 pesticides made by Mozambique. And then there was a lot of questions about these notifications were not sciencey enough, or like as high standard as what developed countries would do. I think this is what need to be recognized in for the global south, is that they do not we have scientific methods there, but they do not necessarily have the capacity to do everything according to the highest scientific standards. So I think such a body can also help them to build up the capacity there. And I think this is also, this will be my immediate reflection. Thanks.
Very good. Thank you, Zhanyun. And next, Felix.
Thank you. I think that it's an important topic. I think one of the things that we also noticed, the panel, they should provide advice. It's also helpful for countries. And when we talk about countries, we talk also about developing countries. So I think the advice is provided, it should be helpful for all types of countries, perhaps in particular LDCs. It should also be helpful for small and bigger countries, more or less resources. I think it's key that the Global South is fully participating in the Intergovernmental Panel when defining questions, that they can be helpful for them also the responses. And one more thought about that, I think also that perhaps also was Marian also has mentioned, this question of implementation, that the Science Policy Panel should also address this part of where we are lacking implementation. Why are we not better in implementing things that we know? That could also be an aspect to be considered that could be helpful for the Global South. Thank you.
Thank you, Felix. Paul?
They need to be fully involved in the governance structure of an assessment. And so that is the plenary and the bureau. So for example, in IPBES, the bureau has 10 members, 2 from each of the UN regions. So 2 from Africa, 2 from Asia, 2 from Latin America, 2 from Europe and USA together, and 2 from Eastern Europe. They also have to be full members of the a multidisciplinary expert panel. And again, in IPBES, it's exactly geographically balanced, 25 members, 5 from each of the UN. So there's more individuals from developing countries on the Bureau and on the expert panel than there are from developed countries, basically. When we choose experts, also need appropriate geographic balance. And so it's not exactly 2020, 2020 now for the experts in the IPBES assessment, but it's about 30-35% typically from what we call WEOG, USA, Europe, Australia, New Zealand, and Japan, and 65 to 70 do come from developing countries and Eastern Europe. You might need some capacity building, like fellowships for young academics to be involved from developing countries. And clearly, some level of financing is needed to ensure developing countries can go to the governments can attend the plenary meetings, and the experts can attend the expert meetings. So they're all the features that we have in IPBES, and they're largely the same in IPCC. But IPBES is very geographically balanced and gender balanced.
Of course, I'm in favor of gender balance and all balance.
Exactly.
Yeah. And boy, we need that. Bjorn, and then the last speaker on this will be Satoru.
I think in short, I agree with Marian, what she said, absolutely. If I just look at how this type of work is done in the EU, it provides the answers that I would say for why. In the EU, we always have one expert from each member state. The reason is multiple. The member state where the population is that we're trying to help, they need to have confidence that in what's happening, and that happens through a representative scientist from their country. Having people from all over the place with all sorts of cultural backgrounds, but specialized in the field, means that you get a well-balanced, you get a robust result. You normally don't get the genius outputs, but you get robustness, and that's what governments need to take action. So I'd say that. The one thing which Miriam said, which I didn't hear by others, which I'd like to emphasize, is that those experts, they need to be able to participate, not only by flying there, but they need the time and the abilities, given the abilities to do their science for providing their scientific input. So it's the resource issue is a bit broader than the simple flight and going to a meeting. I know Bob didn't mean that, but I think I just want to emphasize there needs to be some equality in terms of the ability to provide input too.
Very good, thank you. Yes, it's not just the composition, but the ability to contribute and to have scientific capacity, capacity to participate. And Satoru, finally, your comment on this question?
Yes, thank you. And actually, I would like to echo what has been said today by previous speakers on this topic. And for me, as I mentioned in my talk, the top priority is to encourage countries with inadequate capacity in terms of chemicals risk assessment and risk management to move forward, taking into account their individual conditions. So efforts need to be made by international societies, such as in the area of the technical aspects as well as financial aspects. Chemicals pollution is a global one, and it cannot be controlled properly without collaboration of the countries along with the value chain of the products. It's, I think, very crucial for ensuring all the countries' participation in the chemicals management. Thank you.
Thank you very much for answering that question. We've got just a little bit over 30 minutes left in the panel discussion, so we hope to take several more questions. So the next question, we're not going to get into slightly tougher questions, so just a warning. Given that chemical policy is now severely underfunded, such as SciChem, how will this panel be funded? And how can we ensure that funds are not diverted from processes and activities that aim right now at managing chemicals? In other words, we have to ensure that funds that are now being used to manage chemicals and waste are not siphoned off into supporting this new initiative. So here's the order. Felix, Bob, Björn, Satoru, and Zhanyun. So Felix, if you want to start on this question, how can we fund such a body?
I think one key element is that we achieve a panel that is substantive, that has relevance and high standing. That's also why we go for the, if you want, the highest standing as an intergovernmental panel under the UN. Because we think if it's relevant and considered as relevant, then governments and perhaps others will be ready to support it. I think it also has been mentioned before, and I said it also before, the budget of IPCC or IPBES is not that big. It is also possible because there's a lot of support. So if you have reports that are of high standing, those kind of a prestige that are relevant, I'm very sure that academic scientists are ready also to support this work by providing inputs and work to it. I think also we have to go beyond the chemicals silo. That is also why we think that this panel has to be rooted within UNEP and WHO. So we have the health and environment. That could also be additional income. And then, as mentioned already before, I think also if you gain visibility, if you play on a higher level, higher recognition, that will also increase the funding because the relevance of it will be considered. Thank you.
Very good. Sorry, my mouse didn't cooperate with unmuting myself. Bob?
Yeah, I mean, I liked Felix's answer. In fact, I think I could have given Felix's speech and he could have given mine earlier. However, while I would like to agree fully with Felix, we have to realize the IPCC once got into terrible trouble and nearly wasn't funded in the early days. And the US government, for once, luckily it had a Democratic president, it bailed it out in 1 year. It put 75% of all the funds it needed. Since then, it's actually got a lot better, and it's actually it's totally consistent with what Felix said. But basically, IPBES, 3-4 years ago, if it wasn't for Norway putting $8 million in 1 year, IPBES would not have survived either. So I think now, hopefully with IPBES, seeing the success of the global assessment, the regional assessments, hopefully it will be more stable, and I believe it is. But until these systems really come up and prove their worth, like IPCC and IPBES, we've had some significant difficulties raising funds at one time on IPCC, not now probably, but IPBES has always been tight. And the agricultural sector that I directed, it was a challenge basically. So Felix is absolutely right. If we get good products that are policy relevant, demand driven, the money should flow. But in the early days, until the process has got real credibility, it's difficult. Also, the amount of money in the trust fund for IPCC and IPBES is similar, $5 to $8 million a year. But it's complemented by other contributions from governments hosting what we call technical support units, many millions of dollars. It's supported that all the OECD scientists pay their own travel, or their governments pay for it. So the 5 to 6 or 5 to 8 million is actually more than complemented by other in-kind support. So the true cost to governments is probably double what's in a trust fund, and we need to recognize that.
Thank you very much. Yes. Björn?
I don't often answer a question, and it's not because often I do answer, even if it's outside my formal competence. but this one I'm gonna leave. But I will say that I do think it's a real risk. I do completely recognize Bob's and Felix enthusiasm and the fact that value for money, it does generate support. But I've seen in over 30 years of looking at both international and within the EU, and also other countries' chemical programs, that money is finite, and there is a quotation mark fight for it, and it's reality. Even in countries or regions like mine that are extremely well funded, relatively speaking. So it's a real risk, and it needs attention.
Thank you, Björn, and now Satoru, and then finally Zhanyun. So,
Okay, yeah, thank you.
Satoru.
Yes, as I was a governmental official, and based on my personal experiences, my suggestion is that, the missions or the purposes of new initiatives need to be clear as much as possible. It's very important to attract policymakers' attractions, and in order to do so, those kind of new initiatives need to be clearly presented to them. What kind of benefits can be generated through that initiative? So I encourage the scientists to try to identify what will be done, what they will be focusing on. So such kind of the concrete approach is very useful to get funding. Thank you.
Thank you very much, Satoru. And finally, Zhanyun.
Yeah, thanks, Miriam. I have to say that I'm not an expert in the finance part, but I was just thinking that from the previous speakers, also the previous presentations, I would think is that maybe we also need to have a more long-term view here, is that maybe we will need some more substantial investments at the beginning to demonstrate the effects. I think is beyond that, we really need to highlight the urgencies, or I think we shouldn't just assuming the funding is a cake. Maybe the question is not how we cut the cake, but the question is how can we make the cake bigger. And I think this also maybe also bring to the point Satoru has brought before, that is if we have such a body, maybe we can work with the IPCC and IPBES to develop initiatives or actions that can bring multiple benefits, so that with one investment, maybe we can address multiple issues at the same time. This will be also greatly increase the cost of effectiveness. So I think we really need to keep this more long-term view. Otherwise, maybe one day we found out we're buried by persistent chemicals that we didn't notice before, but then there's no way back. So I think that's maybe one of the biggest danger, like the chemical pollution, climate change, and biodiversity, is that there's a tipping point, and we don't know where the tipping point is. So we need to act fast, so that before we cross the tipping point and regret. Yeah, thank you.
Yes, very, very important point about avoiding crossing the tipping point, which invokes the concepts of, for example, the planetary boundary. So moving on to our next question, and I'm going to give you the order first in which I'm going to ask you. Just so then when I'm reading the question, you know who's going to respond first. So first Bob, then Zhanyun, Satoru, Björn, and Felix. So here's the question, and it's a little bit of an elephant in the room. What role would you like to see the chemical industry have in a science policy body, given the importance, and this was emphasized by several speakers, of producing independent, authoritative, transparent assessments? So Bob, specifically, you mentioned that one of the differences between, say, climate science, where most of the information is held by governments. In contrast, for chemicals, the chemical industry themselves really holds much of the information, and a lot of that is held behind a barrier of confidential business information. So the chemical industry holds much of that critical information, and yet, so we need all the experts at the table, but we have to ensure that there are that vested interests are controlled. And I would like to just make one comment that chemical industry is diverse. It's not unified. There are scientists that work in the chemical industry, and then there are the CEOs and the decision makers that drive the direction. So I do think it's important not to see the chemical industry as a monolith. And anyways, yeah, there's the question.
Well, it's clear to me, it's clear to me the chemical industry must be involved. As a very minimum, they need to be involved by promoting their experts to be part of the expert panels in their independent right. They're not representing industry, but their knowledge needs to be brought forward. And we also need industry to be more open about their data. I worked when I was in the British government on neonicotinoids. All of the real information on neonicotinoids and their impact on pollination, most of it was held by industry. We had to work with industry to get that information more freely available, because you can't put any information in an assessment document where you haven't got open and transparent knowledge. A bigger question, and I'm not sure the world's ready for it, and that is, would you have the private sector, the chemical industry, as well as NGOs, as part of the governance structure in a bureau? I did it when I directed the agricultural assessment. It was an incredible social experiment. It was not fully successful, but it brought everybody to the table. And it's worth looking at. Governments were not willing to do that for IPBES. They wanted the Bureau to be purely governments. But is there a broader role for governments? We saw in the third ozone panel called TEAP, Technical Expert Advisory Panel, that looked at technical and economics, rather, advisory panel. It had huge amounts of industry involved, and it was really very successful. So we need to look at the various roles, the strengths and the weaknesses. And the last role would be, again, asking the private sector to contribute to the financing. But it has to go, as I've said many times, into a blind trust fund. They have significant amounts of money, and I think they should indeed contribute to the cost, but avoiding conflicts of interest.
Very good. Thank you, and for sharing the experience from different agreements and arrangements with which you've been involved. Zhanyun, you want to comment next, please?
Yeah. Oh, I really like what Bob really said, a lot of very good points and also many lessons learned. I think I just want to bring in 2 points. I think first is that the private sectors is not only chemical industry. So the industry participants should be wide, like downstream industry users, retailers, financial industries, so that it has a wider kind of representation. And then, like, second is we need to encourage pioneers. So I think also those who can bring the more forward thinking, I think they should be incentivized. Yeah. So yeah, thank you.
Okay, very good. Thank you. Satoru?
Yes. Okay. I have to mention that the chemicals industry has been playing a very big role in chemicals assessment and management, including the research activities on chemicals, for example, the toxicity. So it's very important to engage all stakeholders, of course, including chemicals industry people, so to participate in bigger discussions. And I understand, for example, today's workshop is designed for the discussions among the scientists. scientific communities, but perhaps the next step will require the participation of different communities and different sectors. That's probably the one thing which will be needed for the future discussions on this topic. Thank you.
Thank you very much. And next we have Björn, and then finally Felix on this.
I think this is an illustration of a number of the added complexities that the chemicals issue has around it that might not be in the others. Now, I'm not very informed. I only know what you normally read. I was not an insider in the other bodies. So this might be total unjust and, you know, being self-glorious in chemicals that we're much more complex than others. But I think this is one issue. Data is with industry, knowledge is with industry. Conflict of interest, at least the way it's going, the direction it's going, is a scientist who's been funded by industry cannot participate, at least not in EU bodies. So industry scientists, of course, also not. So this is a complexity. What's the mechanism to get the data out? Because effectively, very often it's an issue of saying, industry, can you please give us the data that gives us a good excuse to ban you? And that is a very different dynamics than you see in other areas. The other thing is chemical pollution is not one problem. You have a problem with some chemicals which are endocrine disruptors in humans and causing fertility problems. You have some chemicals which are persistent and might be blocking you know, the food chain for fish. And then there was the discussion about the other dimensions than just the chemical specialists, who anyway are very, very broad, or let's say, which is very broad in theme, which is a big challenge. And then finally, I don't know the biodiversity side. I do know the climate change side. There's a lot of public money that goes into funding researchers. So there's a big pool of researchers who have no conflict of interest because they manage to do so good research that they get the public money. If you look at where public money in chemical go, I mean, there's not very much public money that goes into chemicals research, which basically means that a lot of the professors who are very, very good, very brilliant, they need to get money from industry in order to pay for their postdocs. So the whole financing structure of science is different. Another dimension of complexity. So all I'm saying here is I think there are a number of points here that need extremely careful reflection. And since a body like this that you are thinking of creating, wanting to create, needs to have the trust of the global public, but also the global policymaker, the conditionalities will not necessarily always give you the best scientists.
Thank you for adding more complexity to an already complex situation. But we've got to be aware of complexity. After all, this isn't for the faint of heart. And Felix, do you want to close out this question, please?
Thank you very much. Yes, I would like to support also what others have said, in particular that when we talk about private sector, we talk about more about the chemical industry. You know, we have also retailers, downstream, and so I think that's very important to have the whole group there. Perhaps also just one point, I think we have, Björn has mentioned some, others have mentioned other policies on conflict of interest. I think that's very important to create that, because we have to work with the private sector. I would also caution a bit to paint a picture that the chemicals and waste cluster is so much more influenced by the private sector than, for example, climate change. I think also climate change behind there is a very big business. Now, when you think about oil industry, we talk about coal industry, all those elements. So there are also economic interests are present all over. Not in the exact same forms, also why we say we can't just like copy paste elements from IPCC or IPBES, for example, for chemical waste cluster, we have to adjust. And perhaps one last reaction also to what Bob Watson has said now. At the first time I can disagree with you, Bob. I'm very happy about that we don't always have the same.
Yeah.
I understand the concept of including stakeholders, private sector and NGOs in a steering board or in a governing body. I still would say that would not be ideal for this cluster. One reason is that we have with SciChem already an instrument where there's multi-stakeholders, but to my knowledge, climate change, IPBES, biodiversity, they don't have such kind of a multi-stakeholder approach like we have with SciChem. Secondly, as already discussed, this question that we have here about involvement of the chemicals industry, private sector, I think it's also trust building. If we know that governments are in the steering body, that they are the governing body is built out of government representatives. I think that can also be helpful to create this trust and to find good ways how to interact with civil society and with private sector.
Good, thank you. I have a quick question for Bob, because it's a point of clarification. Did industrial representatives delay actions on on implementing the Montreal Protocol in the 1980s?
You have to differentiate. There was a fair amount of good industry-sponsored research by DuPont, Allied, Montifluorus, and 19 companies around the world. They were called the Fluorocarbon Panel. And indeed, they had some of the best research, as good as actually what was funded by myself, actually. I was in charge of the American program, which was the biggest in the world. In fact, bigger than all the other research programs in the world put together at the beginning, $25 million a year. Actually, that research done by the Fluorocarbon Panel was as good as any done by the European academics or American academics and others. And the reason is it was put to incredible peer review, and it had to be published in a reputable journal. And in fact, they had an oversight panel. None of us were paid, and we acted as a really stringent advisory body. And quite often their research showed the ozone problem was a bigger problem than some of the government funded research. So totally different from the smoking stuff, which was all smoke and mirrors and actually highly distorted. So some government, some private sector research can be extremely good. Now, until the evidence became overwhelming, which it did once we found the ozone hole and mid-latitude loss, yes, the private sector tried to slow down progress on banning chlorine and bromine containing compounds, just like the oil coal industry are largely today. But their research, when it was done, was superb. And we had a few scientists involved who worked for DuPont or Allied on the or funded by one of them. And boy, they were superb, because they knew that their fellow scientists would not ever work with them again or trust them if they tried to distort the science. And so I've had a really good experience working with some industry funded scientists and industry scientists on the ozone issue, but they were looked at rigorously by all of us, basically. There was no, but I have to be honest, Felix made the point of trust. There is a lack of trust. So in one of the IPBES assessments, the one on pollination, we had 90 scientists, 2 were for the private sector. And the NGOs screamed at the Bureau, which I was chairing, screamed at the Secretariat. It was a conflict of interest to have 2 industry scientists out of 90. The other 88 all came from academia or some think tanks. And think tanks also have their own views on many things. And so my point was, how could 2 scientists pervert the whole process of preparing an IPBES document with 2 rounds of heavy review by experts and governments? And so there is an issue that some governments don't trust the private sector, some NGOs don't trust the private sector. My view, if it's well designed with good conflict of interest policies, that most of the data does come from journal articles, but some from what I call grey literature that is openly available, then I personally believe we need to make sure that the private sector trusts the processes and actually trust the findings, and having them involved, in my opinion, with all the right checks and balances is very important.
Very illuminating, and clearly not the final word on this, but clearly something to be continued. But we can only continue this for 10 more minutes. So this is the final question. I feel like a talk show host, by the way, which is something when I went into academia, I never thought I would aspire to, but anyways. So the last question is, just to end on an optimistic note, what makes you hopeful that we can achieve a pollution-free planet? And I'm going to go back to the original speaking order now. That starts with Satoru, and then I'm going to read, and Bjorn, I'm going to read Marianne's response, Bob, Felix, and Zhanyun.
I think, yeah, so, anyway, thank you very much for inviting me to participate in this workshop. And after hearing the discussion today, I was encouraged, to embark on new initiatives. I mean, something can be done in order to enhance sustainability in the area of chemicals assessment and management. And I think in order to do that, awareness is the most important step to move forward. So again, I think I encourage scientific communities to play a more aggressive and positive, important role. And I'd like to hear from about the views from the scientific communities, how to move forward. And I am very much excited to work together with yours. Thank you very much.
Thank you, Satoru. Thank you very much. Next, Bjorn.
I think if you look back at the last couple of years, but also even before that, there are events which are absolutely remarkable, which simply are the source of inspiration and energy for addressing the problems which are so evident today. The fact that the Sustainable Development Goals were agreed as they were agreed, in the speed that they were agreed on, and with the unanimity of voice is a world first. I think absolutely amazing. The Fridays for Future movement, which has donned a politicized youth with a clear goal and a very clear voice, very well founded, with its slogan of "Listen to Science," I think is remarkable. I can come with more. I'll just come with the last one. I can speak for 30 minutes on whatever has been remarkable lately. We all have learned to work like this. Is this not democracy pure? Planet democracy that we are just showing here? I think we can reach out, we can gain trust, we can share, we can talk much better, much more intensely, and move a lot more simply as the one positive aftermath from Corona, that we can sit in our living rooms, see our dear ones in the evening, and still have this type of conversation, I think is absolutely amazing. And by the way, just think of all the CO2 we've just saved today. Many. I can continue, but I'll stop for the sake of time.
Thanks, Bjorn. And your comments bring to light, what several commentators like Thomas Homer Dixon and Catherine Hayhoe have been talking about, is the power of hope, and not just hoping that something will happen, but to hope to bring something to fruition. I'd now like to turn to Marianne's response to this. And she wrote, a pollution-free planet is an ideal situation, which is almost impossible to achieve, but a planet with reduced pollution is possible. This is because the very essence of living life is associated with pollution, from the discharge of bodily waste to mundane activities such as cooking and seeking firewood. So it's not that we can ultimately avoid waste, but it's how we manage it. So to suggest a pollution-free planet is to suggest a planet with no humans, but therefore, Marianne recommends moving forward with responsible consumption, application of green chemistry principles to the chemical industry, exploration of alternatives, less toxic fuels. And now with that, we'll close with Bob, Felix, and then finally Zhanyun. And sorry, we only have about 4 minutes left.
First, I'm an optimist by nature. I don't think we'll see a pollution-free environment in my lifetime, but we can definitely limit the pollution, consistent with the last answer. I'm optimistic because I do now see governments working with scientists, working with the private sector, working with civil society. The World Economic Forum 2 years ago said the 5 biggest threats to the sustainability of industry were all environmental. This year, of their 5, it was 4 environmental, including climate, biodiversity, pollution, and pandemics. So I think we are, and Björn said it very well, I agree with his answer, we're all moving in the right direction.
Yes, thank you. And I can tell that you're an optimist. Otherwise, you would have quit the business a while ago. Felix?
Yes. For me, also a reason to optimism is people like we have here today attending this workshop, at this panel and so on, the people I work in this community of chemics and waste. I see so much commitment, so much willingness to find better solutions, to improve it. That's already a reason to be optimistic. Secondly, as others have said, environment is back on the top of the international agenda by good reasons, not very fortunate reasons, but good reasons. And we will get the attention we need to avoid those tipping points that Zhanyun has mentioned. I think also that new concepts coming up, stronger concepts like circular economy is getting a big push. So they will also help to combine these elements of that we have a certain living standard that people want, perhaps also deserve, and to find to it in a sustainable way. So I'm very optimistic about that those concepts will bring us forward to find a way to balance those needs together and achieve this less polluting kind of economic system that we need.
Very good, thank you. And Zhanyun, you get to wrap up.
Yeah, thank you. I will have very shortly. I just wanted to say that, like looking at today's workshop, we have many great minds here, and we have also the participants from all over the world. So I think we're slowly building up a strong community. I think at the end, it's us people, we solve the problems. So I'm very hopeful that we can build the community stronger and stronger and really work together and solve all these issues. Thank you.
Yes, thank you. So with that, and with I think 1 minute to go, I'd like to thank you very much. The first thing I'd like to do is to thank all the speakers and all the panelists, because, well, without you, we wouldn't have had a workshop. But it's really without the audience, we would have had no reason to have the workshop. So thank you very much for participating in this workshop. And for those of you who signed on, this really gives more momentum to bringing forth a science policy interface body dedicated to tackling key issues of waste, chemicals and waste. Before closing the event, I would like to invite you to fill in a brief survey to help us improve future events. And the very final thing I want to say before turning it over to Martin, if Martin has some final comments. I thank the speakers, but I have to thank Anna Zell again, because as executive director of IPCP, she made this happen. And I'm so grateful, Anna, to you. there's been, I'm grateful to Martin Scheringer, who started along with Oki Bergman, the IPCP, and has devoted so much energy to keeping the IPCP going, for hosting this, for bringing forth important issues. All the members of the IPCP. And I'd just like to mention a few who are behind the screen, who you haven't seen, and notably Marta Beignet, Leona Nusser, and there's been important technical backup from Thomas Backhaus and Asa Arenas, and from Penny Vlahos. And with that, I've said enough thank yous, and I turn it to you, Martin, to close out.
Okay, I don't have to add anything really, and I thank you, Miriam, for the wonderful closing words. I just wanted to reiterate the point of the survey. We have even a slide that shows that there's a link to a survey with 4 questions you would like to ask the attendees to fill in, if possible, if they have a couple of minutes for that. And that's all from my side. Thank you to everybody. And it's a rich outcome of the workshop, and we will also, I guess, be in touch, or we will inform everyone about future or follow-up steps. Thank you.